This 3 hours long data modeling masterclass for data engineers covers all the ins and outs with practical code implementation from scratch, and eventually will cover some complex concepts such as incremental data load, dynamic data load, slowly changing dimensions, star schema, and much more. There are so many data engineering techniques that we have available in the industry, but being a data engineer, you need to understand what are the specific things that you have to master as a data engineer. Plus, you need to align all those things as per the latest architecture instead of just implementing it on on-prem servers. Why this is a complete guide for you? Because I have referred to so many books, documentation, to my own notes as well, so that you do not need to struggle with this particular area anymore. And yes, I just want your love and support for this channel, and I know you love me a lot. So just let's get started with this video, and before that, just hit the subscribe button and I know you will show your love as well. So let's get started. So what's up my fam? Happy Sunday. What's up everyone? Are you excited for today's video? Data modeling from zero to pro. I got so many DMs, comments, so many basically requests to create a dedicated video on data modeling, because I realized that we actually do not have a dedicated video on data modeling for data engineers. We have for data analysts, where everyone talks about normalization, first normal form, second, third, blah blah blah. No one is actually talking about data modeling for data engineers. It is totally different. And the ones who do not know the difference, they just watch those videos with data modeling, which is actually not relevant to data engineers, and they think hey, this is the one. And when they actually you can say are asked the questions related to data modeling, then they feel, oh, this is something that we need to learn first. So I decided to just help you all, okay? And let's actually try to master data modeling for data engineering, because in other roles, in other data roles, you have to just master data modeling. But if I talk about data engineering, you have to master the other things that revolve around data modeling. And our data modeling is totally different than the databases, or you can say the data analysts that develop the data models, or you can say database administrators. So our data modeling is special, and obviously it is much more complex than those, okay? I'm not comparing, but still it is what it is, okay? So in today's video, we're gonna master data modeling, and yes, it will be an amazing session, amazing. And do not worry, this video is for everyone. If you have zero experience with data engineering, if you have, let's say, if you do not know anything, this video is for you. Now you will say, hey, I am an experienced data engineer, I know a lot of technologies, still this video is for you, bro. Because the thing is, maybe you are aware of some technologies that we have in data engineering, but data modeling is something special that not everyone knows. Or if someone knows, maybe the depth, maybe the concepts, maybe the fundamentals, maybe behind the scenes are not actually covered, okay? So this video is also for you if you are a pro or seasoned data engineer, So just wait and watch, because we're gonna start from zero and we're gonna level up with the time. Plus we're gonna talk about everything, how data modeling goes hand in hand with data engineering field. Because being a data engineer, we develop ETL pipelines. Do not worry, we will talk about ETL pipelines as well, but I'm just giving you some hints. So we have to just take care of data modeling at each and every step of our data movement. It is not just about building the data model at the end, at the last stage. No, we have to take care of our data model since the very first stage. So in this particular chapter, in this, you can say not chapter, in this particular course, in this particular end-to-end video, you're gonna master data modeling, okay? But before that, I need to talk to you. It's very serious. If you are new to this channel, just hit the subscribe button right now, because this channel is, you can say, gold mine for you. If you are in data engineering, if you want to become a data engineer, if you are thinking to become a data engineer, if you are already a data engineer but you want to gain skills with the modern tech stack, I am not saying this, who else is saying this. So you can just trust them and just hit the subscribe button. Just help this channel to grow, because on this channel you get real knowledge for free. Okay, you just need to bring your time, and in return you will get the knowledge, the depth, the hands-on that is very rare. Okay, and some people say like it is even better than the paid courses. So if they are opted in paid courses, and if they feel after watching my YouTube videos they are better, so it is their review, so you can trust them. Okay, so now I will simply welcome the new members of my YouTube channel. So let's welcome Salman, Venkatarao, Amram, Teach, Rohit Javeri, Neelam, Adi Reddy, Fani Divi, Nageshwaro, G Kaur, Ratnakar Reddy, Parth Paul, Julio, Titan of Trade, Sagar Tyagi, N. Blan Joshua, Louis, Jyotirmoy, Kuntal, NW Technet, Prachi, Ahmed, Chiluka, Star Villa Fleur, Yadiki Rajesh, Lakshmi Chaudhary, Dhanush, Sai Pavan Gade, Raghunath Singh, Anuj Gaurav, Priyadarshini, Najib, Zan, Sandeep Sirvalkar, CV, Sandeep Chandu, Mani Chand, Nagubadi, Calvin, Jeevan, Fred, Bhardwaj, Jamunaji, Joni, Basha, Anupriya, Mathu Vyal. If I missed anyone, so sorry. Okay. By the way, I just tried my best to just keep everyone else in the loop. So if you also want to join this channel, if you also want to support this channel, if you also want to contribute to this channel, simply hit the join button and you will be the part of this loyal data family group, or you can say community, or you can say family. Okay, so now let's get started with our amazing data modeling masterclass, or you can say course. And I have just set a target of this video. So let's let's say the target of this video's number of likes is 1000 likes. So it's your duty, it's your responsibility to get the 1000 likes on this video and 300 comments. It's not too much. You can just fulfill it very easily. So just go ahead. It's your responsibility, and I want it, and I want it. Okay, simple. So let's get started with our video, or you can say master. And we have a few names that I missed. Okay, so now I just got them here. AB, Manish Bhosle, Raghunath Singh, Anuj Gaurav, Priyadarshini, Najib Chan, Sandeep Sirvalkar, Vasudev Krishna Mata, CV, Sandeep Chandu. Some names can repeat, but it's fine. It's my fam, so I can just take some names again and again. It's fine. Kelvin, Neha Pancholi, Jeevan Kumar, Fred, Teach, Bhardwaj Sharma, Jamuna Ji. So do not feel sad. You are my fam, so I will take care of you. Don't worry. So let's get started with our. So first of all, let's talk about what is exactly the data modeling. Okay, because everyone talks about data modeling. First of all, let's try to understand it. So basically, data modeling is the process of creating a blueprint. Now, what is blueprint? Blueprint is a kind of, you can say, high-level architecture, okay, of how data is stored, connected, and retrieved in a system. That means you are obviously, being a data engineer, ingesting a data, okay, making API calls, pulling the data from SQL servers, pulling some files, everything, right? But you are actually storing that data in a destination. Make sense? So this is a kind of blueprint that how you will store that data. The technique, the strategy, the approach is data modeling. The data model. How you will model the data. Now, as a data engineer, it's not just about pipelines and tools. No. You need to design data structures that support reporting, scalability, and performance. So as I just mentioned, that being a data engineer, we develop pipelines. So we have to take care of all these stages of data modeling. Yes, data modeling is the last stage of your data engineering task, but being a, you can say, good developer, or you can say a proficient data engineer, you need to take care of all these stages with respect to your data modeling, or you can say with respect to your data model. Make sense? So when you are just actually taking care of data model in all the layers, you are actually following the right approach, because you do not need to worry about anything, right? Now let's go beyond the definition of data modeling. Let's see why it matters. Let's say we are talking about data model. Why it matters? Because it makes data easier to understand and use. Because at the end of the day, whatever data you are preparing, whatever data you are modeling, it will be used by some stakeholders, right? It can be data analyst, data scientists, business managers, BI developers, anyone, right? So obviously they will be writing some queries on top of your data. So it improves query performance as well. Okay. Plus it helps you to build scalable systems. So let's say today you build a data warehouse, or let's say you build a data model. Tomorrow you need to scale it. Let's say you want to add more tables in that particular data model. You will not be designing a new data model if you just want to insert some, let's say, 1 or 2 tables. So data modeling and data engineering is designed in such a way, if you want to scale it, you can. How and why, obviously these questions will be answered very soon, but first try to understand like what exactly you need to do as a data engineer, right? Now, okay, this is also clear. Now let's talk about something technical, which is types of data models. Okay. So these are the types of data models that are there in all the forms of data models. That means either you are a data analyst or database administrator, building data models for OLTP databases, OLAP databases, anything. These 3 types will be there. The first one is conceptual. That means before building a data model, you build a conceptual data model, which is just the high level overview of your model. It can just contain entities such as customers table, orders table, products table, you can say sales table, all these things, like high level overview, like how you will actually keep the entities simple. And you can say their relationships, but relationships not like in deep relationships, just the high level, because relationships and all those joining, you can say, strategies will be discussed in the logical data model. This is the second stage of your data model. When you just try to create relationships, you just try to find the primary keys, you just try to find, you can say, joining conditions and all those things. Make sense? So now this is just like the logical thinking, you can say logical step of your data modeling, where you are just building the logics. Okay, very good. Here you do not need to worry about data types or DBMS, nothing, because that particular thing will come under physical data model. Physical data model means the real data model that we actually build. It is the implementation step. Okay, here we take care of the data types, constraints, indexes, partitions, you can say triggers, everything. So this actually goes in a flow. First of all, you build a concept, then you build the logic, then you actually build the physical data model. So these are the 3 different types of data models that you should know. Very simple stuff, very fundamental stuff, but very important stuff. Okay, very good. Let's talk about now the thing which is really, really important, which is OLTP versus OLAP data models. As I just mentioned in the beginning of this video, that you are a data engineer, right? So you will build different data models if you will compare yourself with anyone who is working with the databases, who is a DBA called database administrators. So your data models will look very, very, very different from those data models. Let's try to expand this topic, because this is, you can say, one of those fundamentals that you cannot ignore. First of all, let's talk about OLTP. OLTP stands for online transactional processing. Okay, very good. Online transactional processing. Okay, so these data models are designed in such a way that can handle transactions easily and efficiently. Now, what are transactions? Transactions, you can imagine or relate this concept with, let's say, you have a table, okay, in which you are writing the data very, very, very frequently. Very frequently. So these OLTP data models are designed in such a way that it can handle writes, efficiently and very fast, because that is their core, you can say, use case. They want to store the data, whatever they are getting, immediately. Make sense? So DBAs, or you can say database people, sometimes database administrator, sometimes database analyst, build data models for OLTP databases, and they use an approach called normalization. This is their core data model, normalization, in which they try to normalize the data. Now, what is normalization? Let's talk about this. So basically, let's say you have a table which looks like this. Let's say you have here ID, okay? Then you have, let's say, name. Let's say you have here department, okay? Here you have 1, 2, 3, okay? Then let's say here you have department name, or department, you can say, or company, okay? Then you have name, let's say AA, BB, CC, and department, whatever, like IT, HR, or let's say this is also IT, okay? And company will be, let's say, same, XYZ, XYZ, XYZ. So what happens in, you can say, OLTP databases? They do not keep redundant data, okay? They do not keep the redundant data. So as you can see, this data first is redundant data, second is that data which actually doesn't belong to this particular table. So basically they have different forms of normalization. The first one is first normal form, which says like every record should be uniquely identified. Then they have second normal form, then they have third normal form. These three normal forms are very popular. They have, I think, till 6, but they just normalize the data based on level 3. Yeah, that's it. They do not go beyond that. So they do not keep, let's say, company data within the, you can say, ID, name, and department data. So they will simply create a different table for company, and they can simply define the company like this, company and company name. Let's say company ID is 1 and XYZ. So they will simply say 1, 1, 1. They do not want to keep data like this. And similarly, maybe department for department as well. So they will simply try to normalize the data as much as they can. They do not like keeping the redundant data, and they simply replace that with a different table, with a different, you can say, totally different table, and they simply assign the key for it. And this behaves like a foreign key here, and this will be the primary key. This is a kind of, you can say, normalization, or you can say data modeling that OLTP databases or OLTP data models create. But do you know what? In OLAP databases, which stands for online analytical processing, so this is something different. This doesn't say, hey, just normalize your data. Yes, we normalize the data, but not entirely. We keep a blend of normalization and unnormalized, you can say non-normalized, or whatever word is this, the opposite of normalization. So we keep a blend of both, because what we create in OLAP databases, obviously we're gonna just discuss OLAP data models is in very much in detail. So just for the hint, we use something called as dimensional data model. We do not say, hey, if you have the customers table, let's say like this, who is calling me? So let's say like this. So let's say this is the customer data, okay? Like this. So now the same table that you created before, so you can simply recreate it. Now we will not say, hey, just create another, you can say, table for company. the same column that we created XYZ, 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 we will keep this column. Why? Because it belongs to this particular customer, or you can say employee. Okay, employee will be better, because this belongs to this particular employee, plus this is a contextual data. This is what? This is a contextual data. So we just try to create tables based on the nature of the data. We create tables based on the nature of the data. If we have, let's say, contextual data, which can add some context, we create a different table for it. And all the numerical data of this particular table goes to a different table. So we have a totally different approach to build the data models. OLTP is entirely like different. OLAP is totally different. And approach is also very different. Very, very different. I personally haven't built much OLTP data, you can say, models, because obviously DBAs, which are like database administrators, build these kind of OLTP databases. If you are a data analyst, it depends. You may or may not build OLTP databases, because we treat OLTP databases as our source. Okay, as our source. We do not create OLTP databases. All the data professionals, data analysts, data engineers, data scientists, we use OLTP databases. But obviously in some organizations, if you are wearing multiple hats, so maybe you will be building OLTP databases. It's totally up to the organization. But if I talk about the core standards of the industry, we use OLTP databases. We do not create OLTP databases or OLTP data models. Make sense? We just use OLTP data models, but we create OLAP data models from scratch based on everything. So this is like very high level overview of the difference between OLTP data model and OLAP data model. So now you can just feel the difference. Like this is the core of your particular niche, of your particular industry, OLAP data model. Okay, so we gonna cover all the things, because when you build OLTP databases, you do not need to travel your data. You simply get the data, you store it, you model it. But here, you actually travel your data. You create multiple layers and you refine your data with those layers and you model the data. So you have to keep a track of so many things other than just like storing the data and modeling it. Make sense? That's why this video is like end-to-end example of the whole, you can say, journey of data. Right from the OLTP, like we will simply use the source and we will just travel that data and we will just create our data model, which is OLAP data model. I hope it makes sense. Okay. So don't worry, we're gonna just see a lot of practicals, a lot of hands-on, everything. So just be with me, everything will be discussed. Okay. But we will be discussing all the things, not just OLAP database, or you can say just OLAP data model. No, you have to just, you just have to master like the whole journey, right? I cannot stress much on this particular difference. It is really important. So let's see what do we have next. Just a quick overview, because I know you are a very enthusiastic cloud, or you also want to just learn the modern tech stack. Yes, we have some amazing cloud data warehousing modeling softwares: Snowflake, Databricks, Synapse Analytics. We have some more as well. BigQuery, Google BigQuery is very popular tool. Then we have Redshift. We have so many tools. Okay. But once you grab the concept, the fundamental, only then you can just build those things. Make sense? Only then. So before jumping directly on these things, you need to first understand the concept. But here's a good news for you, because I know you are very, very excited to learn new technologies. For our video, we're gonna leverage Databricks for our platform only. We are not learning Databricks, don't worry. We are learning data warehousing, but obviously we need a kind of engine to process our data, to run our queries. So for the engine purpose, we'll be using Databricks. Why? Because Databricks has recently launched the Databricks Free Edition and it is very easy to set up. So I don't want to waste your time to just setting up the environment and just spending the whole hour in setting up the environment. So Databricks is very easy, and obviously you will have some familiarity with your modern tech stack, if you are really new in the world of data engineering, just imagine you can just add this technology in your resume. So it will be really helpful. Again, we are not learning Databricks, but yes, we are using Databricks to run our code. Make sense? Very good. Then let's talk about the first thing that we need to first of all understand, ETL pipelines. You as a data engineer would have heard about these terms, ETL pipelines, because this is your bread and butter if you want to become a data engineer. Exactly what are ETL pipelines? From the layman language, I can say it is just the journey of your data, or you can say the path of the journey of your data. How your data travel from point A to point B. This is ETL pipeline. So for example, this is your source. This source can be anything. It can be, let's say, your SQL server. Okay. That is OLTP data model. Okay. It can be, let's say, API calls. It can be anything. Okay. Now this is your point A. Your duty, let's say this is you, or I believe in equality, so let's say, okay, you, boy or girl. So let's say you want to travel this data from point A to point B. This is your point B. Now what is this point B? Point B is your OLAP data model. So the entire process from the layman language will look like this. It will look like this. Simple. You will simply say, hey, I used the data from A and I made it available in B. But actually, this will look like this. Ooh. Literally, bro. I will just show you. So actually the journey is like this. Why? Because you need to take care of so many technicalities, all the data quality, all the deduplication, all the things. There are so many things. Okay. So you as a data engineer need to understand what are ETL pipelines and how you need to develop ETL pipelines for your data modeling. Make sense? Because there are so many dependent concepts that you need to understand first in order to build a data model. Because you cannot just directly build a data model. It is very easy to just show the simple example. Hey, this is the data. Build this data model. Tuck. No. You need to understand how we build the data models in the real life. So this video is actually covering the real world examples of data models. Like how you start from zero and reach to the point A, B, C, D, Z, whatever. Make sense? So let's quickly cover ETL pipelines, because ETL pipelines is not like very big thing. It is very simple. ETL pipeline is just a flow. Okay, the path of the journey of your data. So ETL stands for extract, transform, load. Simple. So these are actually the three different steps. The first is extract. First of all, you extract the data from the source like this. Then you perform some kind of transformation. Let's say you want to clean the data, you want to add some columns, you want to, let's say, modify some columns, all those things. Then finally you load the data in a destination. Okay. And then you can say your ETL pipeline is completed. This is the concept of ETL pipeline. And obviously every ETL pipeline is different for different data model. So you do not need to worry about anything. Okay. So let's talk about ETL layers. Yes, we do have ETL layers as well. And you need to understand each and every single ETL layer, because that's how you will actually understand the concept of data modeling, how you want to travel data modeling. So first of all, we have something called as staging layer. Okay. This is our staging layer. What is staging layer? As the name suggests, here we stage the data. That means we bring the data here in this particular layer. Make sense? Let me just make it here. So let's say this is your source and it can be anything. And first of all, you simply, let's use pink color. Let's say you want to stage your data. Simple. Okay. Nothing complex. Nothing is complex. Don't worry. So you simply first of all stage the data. This is called staging layer. Okay. This is the staging step. Now what will happen in the staging layer? In the staging layer, we will not do anything from the transformation perspective. That means we will simply get the exact replica of the copy here of the data. Make sense? Very good. Just be with me. Just be with me. Okay. This is the staging data. Makes sense. Let's say we have the IDs here, 1, then 2, then 3. Okay. And we will simply get the IDs here as well. Let's say 1, 2, 3. Makes sense. Then we have the next layer. Okay. This is layer number 1. Okay. Then we have the next layer. It's called transformation layer. Here we simply transform the data, because obviously this will be messy data. This will be the data with so many, let's say, garbage. Literally, I'm not kidding. You need to transform it. It can be, let's say, adding more columns. It can be modifying the existing ones. It can be removing nulls. It can be replacing duplicates. So many things, right? So many things. This is the layer where you do the heavy tasks, which are, you can say, transforming or modifying the data. This is the heavy lifting area. Okay. I will simply say, let's say 1, and I just created a new column, let's say date column. I simply said 01. Then 2, let's say 01. Let's say month. Okay. 01. Makes sense. Then we have the last layer, which is called load, or you can say serving layer. Here you serve the data. Make sense? Okay. Makes sense. So this particular layer is your end layer. Where you have everything sorted. So in this particular layer, you build your model. Okay. Here you will build your model. Make sense? Make sense? Okay. Here you will build your model. Okay. Now you will say, Ansh, Lamba. So in this particular video, why we are not considering the video directly from here? Because we are just covering data modeling, right? So we can simply start from this layer, because we are just worrying about this layer. Really? Let me just tell you why I'm just covering everything from scratch and why we have to. Let's say you got some new data on the second day. So this is the 1, 2, 3, 1, 2, 3, 1, 2, 3, and here obviously 1, 2, 3. Make sense? Let's say in the source, you got some new data on the next day. Okay. It will look like this. Let's say 4 and 5. Now just tell me one thing. If I will be creating this staging layer, okay, can I pull all data here? The answer is yes, because Ansh Lamba, you said we just create the replica of source. But just imagine the size of data is growing rapidly. Can you load all the data again and again on a daily basis? The answer is no. No. So here comes the concept of something called as incremental loading. So what we do, here I will simply say I want to load incremental data only. So instead of loading this data again, I will load only these 2 records. That's it. That's it. That's why we have to take care of data model right from the beginning. Because now only this data will be traveling ahead. Let's say 4, 5, and this data will be transformed, and this data will be modeled, or you can say this data will be the part of our end data model. Now just tell me, can we create only this layer? No. We have to take care of this data from the beginning itself. That's what I was saying. Make sense? Very good. Now let's quickly cover one more fun fact. Not fun fact, but yeah, just a kind of note that you can create. When we create this staging layer, okay, we have the liberty to create 2 different kinds of layer. One is called persistent and one is called transient. Now what's the difference between these two? So when you want to create persistent layer, let's say this one, then you persist your data in the staging layer. Let's say 1, 2, 3. So this data will also be there. Then new data will keep on coming and it will keep on appending the data. Make sense? It's your choice. It's like company's choice if they want to just keep this messy data. But if you want to create transient layer, then you simply replace this data every time with the new data. In some organizations, they practice transient layer. In some organizations, they practice persistent layer. So it is fine. In our, you can say this video, we will be just going with transient layer because that makes more sense. Okay. And I would say that is more aligned towards the data modeling part as well. Because when you just persist your data, you have to do a little bit more data processing, or you can say more data transformation. But obviously, we are just focusing more on data modeling side. Yes, we need to cover these areas, but in brief. Okay. Then we will simply be using, obviously this layer will be the same. So it is fine. You can keep everything because you have to keep everything in the transform layer. You cannot say, hey, just replace this. No, you have to. It is a good practice and you have to keep all the data here. Okay. But this layer is very special because in this layer, you will be learning about UPSERT command. And I know it's a new word for you, but you will learn this as well. Make sense? This is the architecture of ETL layers that we follow for data modeling. And you have to take care of data modeling right from the beginning. Make sense? And do not worry. This is just like the conceptual knowledge that I'm giving to you. We gonna see each and everything with the help of example and code implementation as well. So do not need to worry. Do not need to worry. Okay. So let's see what do we have next. So where data modeling fits in the ETL layer? Where? So I can just design the, you can say raw, enriched and curated layers. These are, you can say modern day names for the ETL layer. So our staging layer is called raw layer. Okay. Then we have something called as enriched layer, or you can say enriched layer. Then we have something called as curated layer. Okay, so these are the three layers. Our data modeling fits here in the curated layer. Make sense? But it is directly linked to raw and enriched as well. Remember, incremental loading, UPSERT, everything. Make sense? Very good. Now let's talk about something very popular, medallion architecture. You would be thinking, hey, what is this thing? We have only heard about this thing, what exactly it is. So let me just tell you, medallion architecture is nothing but just like the form of, you can say, managing your data within the layers. Remember, I just told you raw, enriched, curated layers, right? So in the medallion architecture, we use the medallion naming convention. That means the raw zone will be called as bronze. The enriched layer will be called as silver. The curated layer will be called as gold. So this is just the renaming of the stuff. Fundamentals, I would say core concepts are exactly the same. Exactly the same. Medallion architecture is very common with the cloud solutions because we use these naming convention. But yeah, you can also use raw, enriched and curated. That's fine. Yes, we do not use the traditional naming conventions such as staging, transform and serving. Those were very popular when we used to just do the on-prem data warehousing. But now we just practice the cloud data warehousing. So we either use raw, enriched, curated or bronze, silver, gold. Simple. But actually the core concepts are those concepts: staging, transformed and serving. Okay. So this is all about medallion architecture and everything that you need to know from the concepts perspective. And I think this is enough for you to actually get started with the hands-on, because now we first need to reach till here. First of all, till bronze, then till silver, because you need to understand how you can incrementally load the data, then how you can just effectively store this data with UPSERT that we just talked about. Once you do that, then you create, or you can say model your data based on the OLAP data model, which is called dimensional data model. So for dimensional data model, I will just tell you how you can just model the data based on the data. So basically, just to give you a hint, at this silver stage here, we simply create one big table. It is called OBT. One big table means you will be having one table with so many columns, right? Like let's say so many columns. Now you will break this one big table into small tables. And these tables will be the part of dimensional data model. See, let's say like this. So this will be our tables in dimensional data model. Like this, like this, like this. So they will be modeled like this. Make sense? But we need to break these tables from this one big table. Okay, make sense? And there'll be one more table which will be the part of this table, and we'll just talk about that as well. Don't worry. So let's actually try to build this solution till here so that we can actually see, hey, how incremental loading works, and then let's talk about then the data modeling part. Okay, let's see. Now in order to just start processing our data, or you can say start with our ETL layers and obviously data modeling, everything, we need an engine, right? We need an engine. You can say computation resource, which will actually process our code, because this particular video is not just about theoretical concepts. This video is concepts, theoretical part plus practical area as well, so that you can actually understand how things work in the real industry, real world. That's how you grow, that's how you learn, right? So for this particular purpose, we would need an engine, any engine, and preferably a SQL engine, so that we can actually perform our tasks using SQL commands, because SQL is one of those things which are very important when you need to perform these things: ETL, data loading, incremental loading, modeling, everything. So obviously there are so many ways. One, you can say very famous way is just to set up a local environment, but that takes a lot of time. Plus you will be just messing up with the data loading, files, and so many things. Okay. So what I thought, the best, easiest and free of cost method, in which you do not need to pay anything, in which you do not need to, let's say, mug up your mind to set up the environment. So the best thing is we want to use something called as Databricks free environment. So recently Databricks just announced the Databricks free environment that's really good. So that means now you'll be saying, hey Ansh, Lamba, we do not even know Databricks, we are so beginners, we are just learning data modeling. So just a disclaimer, we are not learning Databricks. No, we are learning data modeling. We are just using Databricks engine to process our code. That's it, nothing else. We are not going to just see anything in Databricks. We are just using Databricks to process our code, right? You can, yes, use, let's say, your PostgreSQL, you can use your, let's say, MySQL, but at the end of the day, you need to perform those things in cloud, in real industry, right? So it's the best opportunity to get started with these technologies and directly learn these concepts on those technologies, because you are not learning the technology for now. You are learning the core area of data modeling, right? But you are not picking your local environment, you are picking the cloud environment. That's it. So it is the best opportunity for you to just, let's say, be familiar with Databricks as well. Okay. So Databricks free environment, or you can say free edition, is completely free. You do not even need your, you can say, corporate email account, nothing, just your normal Gmail account, and that's it. Now let's talk about how you can set up your Databricks free environment. Just go to Google and just type Databricks free edition and just click on any link. Let's say this link, or sometimes if you click on any other link, it will show you some kind of documentations first of all, like this. Then you can click on try Databricks, and this page will appear, right? Now you do not need to click on continue with Express setup. Yes, Express setup is another way to get started with Databricks, but it is not completely free. It is free for a certain period of time, and after that you have to pay for it. If you want to pick the completely free package for, let's say, till the time they have this particular edition, so click on this thing, looking for Databricks free edition, click here. So just click here and create your account. So just put your email ID, whatever email ID you want to pick, any Gmail account, no student email ID, no work email, corporate email, nothing, normal Gmail account, and that's it. Click on continue. and then eventually you will land on the Databricks homepage. Now, sometimes you will not. So just come back on this link again, click on try Databricks for one more time, and then click on already have an account and login. That's it. When you click on login, then you need to just pick, or let's say put your email ID, or you can pick it from here as well. It's up to you. Then eventually you will land on the Databricks homepage. This is the simplest setup. It will hardly take 5 minutes. Everything sorted, free of cost. Adding cloud to your resume. Best combination, bro. Why to put Postgre, MySQL, outdated things, right? So just play smart, play smart. So now I have created my account already. Okay, so this is my account, this is my Databricks workspace, and you can see it is called free edition. Yes, we are not going to cover Databricks, that's for sure, because this is a data modeling video. And do not worry, because I respect your emotions, your feelings. I know you will be saying, hey Ansh, Lamba, we do not know Databricks and this is data modeling. I know, so don't worry. So now we need to first of all go to workspace. Okay, this is our workspace. Click on this workspace. That's it. Now first of all, just go back to Databricks. If you click on this button, you will see something called as previews. Okay, so sometimes your preview settings will be different from mine, because I might have enabled some preview settings. Like let's say I have turned on so many toggles. So you can, I'm slowly scrolling, so you can make sure like it is exactly matching. Okay, and you can, I would recommend just turn on all the previews, because it is obviously for your benefit. So see, I have turned on all the toggles. Just do this, plus go to settings, then go to developer, and then you can just see what things I have turned on. Okay, and you can just keep the same settings as is, just to make sure like all the features are exactly same, because sometimes in the new versions you see a different UI. So just for your convenience. Okay, got it? Very good. Now let's get started. So I will simply go to workspaces, and this is the area where we can create workspaces. As you can see, I have already created this workspace. This was for my other video, Delta Lake 4.0. If you haven't watched that video, and if you want to learn Delta Lake, masterpiece video, just go and check it out. Okay, and let's create another folder. So basically we create a folder, and it acts as a kind of, you can say, repository. Not Git repository, normal repository, where you just put all the stuff, notebooks, scripts, SQL queries, files, everything. This is a kind of, you can say, root folder for your project. Okay, so I'll simply create a folder, and I'll simply say folder, and this folder name I will keep, let's say, data modeling. Okay, let's say create. This folder is empty, obviously, because we do not have anything. So now in this particular folder, we can keep anything. And don't worry, I will just provide all the code, whatever we are writing here. So you do not need to worry about that. Okay, so now let's do one thing. We know that we're going to perform incremental loading. And in incremental loading, what we need to do? We have a source. We have a source, and this source will actually land in the bronze layer. Makes sense? And this bronze layer data will go to silver. Okay, incrementally. This is our task, and here we will be just performing UPSERT, right? Make sense? UPSERT. Okay, and here we will be performing, you can say, staging, and you already know two types of staging: transient and persistent. You can pick any, transient or persistent. I will recommend you to pick transient, so that you do not need to worry about incremental loading at the bronze stage as well. That's why a lot of organizations prefer transient layers for bronze layer, or you can say bronze data. So it's up to you, it's up to the requirements. But just to keep this simple, we will simply say transient layer. That's it. Okay, so now before even that, we need to go to catalog, and we need to create a catalog. Catalog is nothing but, you can say, a kind of if you're familiar with SQL databases, you can treat it as like a database. Make sense? Like the parent database, not the inner database, the parent database. It is similar to that. Not exactly that thing, but it is similar to that. You can say it is a kind of replacement in particular Databricks. Okay, so you can simply say, I will create a new catalog, click on plus, click on create a catalog, and I will give a name called data modeling. Okay, now maybe this name is already picked. So maybe it can fail if I say create. If not, very good. I will say configure catalog. Before even that, if in your case it is not working, let's say data modeling is already pegged, anything, just say data modeling, your name, XYZ plus, let's try like some different names. Okay. I will simply say configure catalog and then assign to workspaces. That's fine. Click next, then save. And this is ready. Our catalog is ready. And as you can see in our catalog, we have two schemas. One is default and one is information schema. We do not need to worry about information schema, and we will simply create everything in default. Actually, we should create like 3 different, you can say, schemas more: bronze, silver and gold, because in the default schema, we will create our source, right? Because we gonna just create the same situation that we get in the real world. So what we will do, we will simply create a table in the default schema. Okay. And you can imagine that this is our source. Not imagine, like obviously this is our source. Then we need to travel our data within different schemas, bronze, silver, gold. So how you can just create a schema now? So just click on this catalog and then click on create schema. So I will simply say bronze, create, and then I will say click for one more time here, schema, then silver, then click here, then gold. Make sense? Make sense? Very good. Now we have 3 layers: bronze, silver, gold. And in the default, we have a data. But where is the data? So here we gonna create the data source. We gonna create the SQL table so that we can actually load the data incrementally. Make sense? So how we can just create the table? That's where this engine comes into the picture, because we need to write SQL code to create the table, right? So now there are two things. Yeah, there are 2 things. If we go to workspace, this is our workspace, this is our folder. So in this folder, we do not have anything. So now we can either create notebooks or we can create SQL queries as well. Okay. So now both performs the same. Okay. Both perform the same, and performance wise, both are exactly same. So now which one you should pick? Obviously, if you are becoming a data engineer, if you are already a data engineer, I would say you are already familiar with SQL interface, SQL files and all. You should be more familiar with notebooks. There's no difference in the code. You write the exact same code in the, you can say, notebook, but instead of creating multiple SQL files, you create multiple cells within the notebook. And that's why you should be familiar with, you can say, notebooks. So I will recommend just go with notebook. Yes, you can even create SQL files. I'm not saying that you cannot, but I will recommend just go with notebooks. And obviously, I think you are already familiar with notebooks in the Jupyter labs and all, because it is very similar to that one. So I will simply say create, and this notebook, click on notebook. Oh, I have so many notebooks open. Let me just close all. So I am seeing this particular interface where I have notebook here in the form of tabs. So when you will be enabling all the, you can say, previews plus all the settings that I have enabled, just make sure sometimes when you click on previews and you turn on all the previews, just refresh the window multiple times, then go to settings and then enable all the developer settings that I have enabled. Make sense? Still, it is just a UI, nothing else. Notebook is just the notebook, so do not need to worry about that. Hey, I am not seeing here plus button, how I can just do that? Don't worry. So first of all, let's rename this notebook. I will simply say source notebook. Okay, or let's just source. Okay, perfect. So here in this area, I can actually see this catalog. Okay, I can actually see this folder, my parent folder, which is data modeling, and all the things that I have. Currently, I just have source file. Make sense? Okay, and this is the catalog, and this is our catalog name, data modeling, and this is the schema. So now, first of all, you need to click on connect and connect to this serverless compute. So this is a kind of compute which is available in the free edition, and it gets warmed up really quick. See, in just few seconds, it is just like green. So now I will write my code. So this is basically the notebook cell. If you are not familiar with notebooks, I hope you already are, but still. So this is the notebook cell where you write your code, anything. By default, it is a Python cell. Okay. Now if you want to convert it into SQL, you can click on this Python and then click on SQL. So now this is a SQL cell. This is one way of doing it. If let's say you click on plus code. So next code will be Python because default language is Python. If you want to convert it into SQL, you can simply write a magic command %SQL and that's it. It will be automatically converted into SQL. Okay, makes sense? Simple, very good. So you will be saying, hey, which language we will be using? SQL, pure SQL. Okay. Do we just need SQL cells? No, we need Python plus SQL cells. But Ansh, you said we will be just using SQL. Yes, in Python as well, we can write SQL, but there are some functions that I will just tell you. And those are required to just perform all the data modeling stuff in data engineering. Okay. Yes, the code is SQL. Don't worry. We are not writing Python code. Don't worry. So let's remove all these cells. And now let's actually start with the fresh cell. I will click on code and I will say %SQL and I will create a table. So as you know, we first need to create a source table, right? We should have a source table. So I'll simply say create table. Okay. And then I need to define the catalog name. Under which catalog I want to create the table. I will simply say data modeling dot schema. I will pick default. Okay. Then the table name. I will simply say source data. Okay, and see exactly SQL code. We are actually writing SQL code. We are not writing anything fancy. You will say, hey, this is Databricks. We are writing Databricks code. No, just SQL. So now I will simply define the columns with data types, and do not need to worry. I will just provide this particular notebook on my GitHub repository as well. So you can just download. And a lot of you just say, hey, I am seeing .dbc file. There are no notebooks. So bro, this .dbc is a Databricks format. This is called Databricks archive. So when you import this .dbc file, it will import all the notebooks. Okay, so obviously when you click on that GitHub repository and when you say, hey, .dbc file is empty, it is not empty. You need to import this in Databricks. Let me show you how you can just do that. So click on these three lines, go to workspace. Let's say you are here, you want to import that. So let's say you created this folder. Okay. Now you want to import that .dbc file. Click on these three dots, click on import, and then just upload that .dbc file. You will see all the notebooks, all the things will be appearing here automatically. So that is not just a notebook. This is the whole archive version of your code. Okay. So makes sense. Now let's create our table. So these are my columns that I have just put it here. So you can also write the exact same columns with like primary key and all those things. And see, this is just pure SQL. So now after writing this code, you just need to click on this play button. This will simply run your current cell. That's it. It will not run all these cells because obviously we'll be creating so many cells after that. And just a tip, if you want to understand that, if you are really new to the notebooks, okay. So this particular cell can act as each SQL file, right? Each SQL file. Or if you want to create multiple codes within SQL files, when you write colon, like this. So each cell is that particular colon in itself. Make sense? And this is an independent cell. This is not dependent on, let's say, this one or any other one. This will be running independently. That's it. Plus, instead of running this, you can also use something called as Shift plus Enter to run the current cell. Just go to that cell and just hit Shift plus Enter and that's it. Okay. And I can also add a guardrail if not exists, so that we can just run it multiple times. So now I'm just running this again. So that's it. So it will simply say create table if not exist, and that's it. So now if you want to just insert the data, I will simply say insert into, and this is throwing error. Why? Because this is a Python cell. So simply convert this into SQL. Okay, perfect. So I have simply write initial load, and these are my values for this particular table. Let me just run this as well, just to show you. So once this data is inserted, what is saying? Okay, perfect. So now it is saying, hey, you are inserting data into sales orders. You simply need to write your first of all your catalog name. So I forgot that data modeling dot default. So see, this is very good thing about Databricks. It gives you suggestions as well. Why? Because they have something called as AI enabled within the code. So whenever you'll be writing, you will get the suggestion. That's the best thing. I would say that's a kind of vibe coding that is available in Databricks, and that actually saves a lot of time. Initially, you will not feel that, but whenever you will be building some stuff, it's amazing. It's amazing. So data modeling dot default dot source data. Perfect. Let me just run this. And once the data is inserted, it will take hardly few seconds. We just have like, I think 1, 2, 3, 3 records. That's it. So now in order to see the data, I will simply say %SQL select asterisk from default data modeling dot default dot source data. Just run this. So see why notebooks are so convenient. You can actually create so many things within just one notebook instead of just creating so many files, right? And it actually saves your progress as well, because you do not usually save select statements in your queries, right? But here you can save. So this is our data and it is looking amazing. Okay. And as you can see that we have so many columns. That's what we want. Why? Because we need to just break this one big table into dimensions and fact tables, right? That's our goal as well, but incrementally. That's the best thing that we are going to do. So this is our source. Our source is ready. Make sense? Very good. Now what I will do, I will create a different particular, you can say notebook. I will click on plus here, or I can just go to this folder. Okay. And I will say create notebook. If you do not see this option from here, you can obviously go to this particular 3 bars and then go to workspace, and then you can create from there as well. And then you can simply click on this. Same thing. Do not need to worry. Just you can say UI difference that usually changes. Okay. Do not feel like in my system, I am seeing black color, in your system, you are seeing gray color. This is something totally different. I don't know. Do not behave like this. So now let's create our bronze notebook. So as discussed, first of all, just connect this serverless compute here, and yeah, that's it. So as discussed in the bronze layer, it is also called a staging layer, right? Where we just stage our data. Okay. And there are 2 types of staging, transient and persistent. Okay. The benefit of transient is it actually takes care of the incremental data load and at the bronze layer level automatically. Why? Because every time you just load the incremental data part only. Make sense? You just load the incremental data load part only. But when you create persistent layer, it adds a little bit of manual work where you have to manage the incremental loading at the bronze layer level as well. That's the only difference. Which one to pick? I would say both are the same. In the industries, they pick both. It totally depends upon the project requirement. So you do not need to worry, hey, should we go with transient? Should we go with persistent? I would say start with transient layer. Usually, like with the course of time, usually you will see, hey, this project is using persistent. Let's try persistent as well. That's how you evolve. But start with transient. Okay. So I will simply create a table. So in the transient layer, what we actually need to do as per our fundamentals. In the bronze layer, we do not perform any kind of transformation. We just create the exact replica of our data, right? So I will simply say select asterisk from this source, right? And what is the source? Data modeling, default and source data. Very good. But here, this is an incremental load. So I will also say where order date greater than something. Very good. Now comes the concept of incremental timestamp. So I will simply create a code here. Okay. I will define, hey, what is my, you can say last load date, because I want to perform, you can say incremental loading, right? So initially, so if I go to source, you will see that in the order date column, we have all the dates. Let's say 2024, 07, 01, 070. This is like just one day of data. Like on the very first day, these are the records. These are the orders that your organization has received. Okay. Okay, perfect. So initially, as per the industry standards, what we do, we simply pick like very old date. What do I mean? Very old date. So this is 2024, right? We will simply pick something called as, let's say, we simply create a variable called last load date, and I will say 19000101. Obviously, in 1900, did your organization receive any kind of orders? The answer is no. Okay, you will say yes. Okay, just pick 1800. Did your organization receive orders? Maybe. Okay, just pick 1700, or let's say 1000. Okay, now you happy? Now you happy? Very good. So now this is the last load date. That means this is the timestamp when our last data was loaded. We want to load all the data after this particular date. So why we pick so old date for the initial load? Because we want to load all the data. We want to load all the data. Make sense? Okay, very good. I will simply say greater than last load date. Let me first of all run this. Perfect. Last load date. Okay. So now here it does not perform like this, because this is a SQL command, and you cannot just put SQL, you can say command with your variable, right? Makes sense? Obviously. So here, if I write this, it will work. If I write something like this, let's say this one, obviously it will work, and it will give you all the 3 records. It should, yeah, that's what you want. But we want to make a dynamic solution, right? Because in the real world, you will be changing this timestamp based on the what? Based on the data that we have. Data that we have. Very good. So how we can just perform that thing? Like how to just make this particular solution dynamic, and how we can just take care of those things. So basically what we do, that's where we use something called as Spark.SQL. Okay. So you will simply remove this %SQL command, and you will change this cell back to Python. Don't worry. Just stay here. Okay. Just change this thing to Python. Then just replace this cell, like this code, with this particular variable name. Perfect. So now this is dynamic solution that we want. But in order to run this, we need to use SQL with respect to the Python API. That means you will use something like this, Spark.SQL. Okay, then just close everything in the parenthesis, then just put 3 double quotes and 3 double quotes at the end, and then just close the parenthesis. That's it. This is your code. Okay, now this is a variable. So if you have some basic understanding of programming language, very basic, we use something called as f string, right? So you can simply say f, and you can close, or you can say basically wrap this particular variable in the curly braces. Now this is the thing that you have to perform. Make sense? If I just run this now, okay, we have something, cannot resolve order date 1000 minus 1. Yeah. So basically here we need to write something like this, like single quotes, and perfect. So this is done, because obviously whenever you use date column, we use single quotes, right? Common sense. Now this is created. So this is what? This is a kind of data frame object. Whenever we use Spark.SQL, it creates a data frame object. But Ansh, how we will just store this particular query, and how we'll just create the table? So many questions. I know. Hold on. Now what we do? We simply create a particular thing. It is called temporary view on top of this particular query. So you can simply say dot create or replace temp view, not global temp view, just temp view. Okay. When you click on this, just close this with open the parenthesis and closing parenthesis. Now just run this. What will happen? Okay. I just forgot to type the name. So I will simply say source, or like let's say bronze source. So this is the name of my view. Let me just run this. So now, do you know what actually happened? You created a view on top of your dynamic query. Now I can access this using my normal SQL. Select asterisk from bronze source. See, it will work. Temp bronze source is spelling different. Yeah, I just gave bronze. Just corrected, bronze. Okay, now let's run this. Okay, perfect. See, it is working. So that's how you create or use SQL with data modeling. Earlier, these things were handled by your procedures, stored procedures in SQL, but with the time we evolved and we started using something called as Spark engine, and we have SQL engine within that. And that's how we leverage, you can say, incremental loading, dynamic queries within that. Yes, the older way was just using stored procedures to load everything using the functions or procedures, everything, basically stored procedures. But this is the modern way of doing it. Makes sense? Whenever you're working with cloud, whenever you're working with, let's say, big data things, this is the way. I'm not saying like those on-prem, your stored procedures, Postgres stored procedures are gone. No. Companies still use those things as well. But in the data engineering world, those are being replaced slowly because they want to just leverage the big data engines. Stored procedures are very much handy when you are just building an OLTP database for database administrators, but you are building a data warehouse. Okay. But yes, earlier when we used to work on-prem, we used to build those things in the on-prem. But now this is cloud. That's the difference, and that's why I picked cloud, so that you can learn the modern things, bro. Okay, so this is done. This is your select query. Now I want to create a table on top of this particular query. So whatever data I will get in this particular view, I want to create a table on top of it. Simple. So how I can just create that? I will simply say create or replace table, because we are creating a transient layer. Okay, table, and I will simply say data modeling, my catalog name, dot bronze, dot this will be, let's say, bronze table. Okay, bronze table, and then I will simply say as, and then select asterisk from bronze source. Make sense? I will simply run this and it will create a table for me, and I will show you, don't worry. Perfect. So now if I just go to catalog, data modeling, bronze. So this is my table and my bronze table is ready. Now we can use this bronze table to go to the silver layer, but before that, I need to just tell you one thing. So basically this is the last load date. Make sense? This is the last load date. Initially we defined this thing 1000-0101, that is fine. But for the incremental things, let's say for the incoming iterations, how this value will be changed, that should be your question. If you haven't asked me that question, what should, like, how we can just pick this particular thing? Makes sense. How? So in that particular scenario, you have two things. Obviously we use, let's say you are just building these notebooks. These things should be changed at the pipeline level. Let's say you will create a kind of parameter here. Let's say using DB utils. I don't want to go deeper in Databricks, so that's why I'm not going in that way. So let's imagine you just have this parameter, or let's say variable in this. You feed this variable, or let's say feed this parameter through the pipeline. Yes, you can build the logic in particular, let's say in notebook as well, but we are just going with the data modeling part more. So these are the things that we manage at the pipeline level, but your concepts should be clear, crystal clear. So what happens? So let's say you have this variable and initially we define this particular value. Okay. Every time you can override this value using the pipeline. You will simply say, hey, this variable should be 2024 01 or whatever the value was, 07, let's say 01. This should be the value. Let's say tomorrow the value should be 2024 07 02. Make sense? So you can do a lot of stuff. Yes, you can. And it's like all in your hands. You can just do whatever you want. In the pipeline level as well. Yes, some people do manage this thing in the notebook level as well, but that's up to you. I'm just telling for the bronze layer because it is like totally subjective to the project requirements, and you can say design or the architecture of the project. But yeah, there are like infinite ways to manage this particular variable. Yes, this should be dynamic. That's your core concept. That's it. Because every time this value will be changed, or let's say any value, it will simply give you the results based on this particular thing. Perfect. And on top of this, you will create your table for the bronze layer, and it will be going to the silver layer. This is the core concept. Simple, sorted, nothing fancy, I think so. So now our bronze layer is ready. Okay. Now I will click on this plus icon. I will simply say new notebook, and if you do not see this button here, you can click here and then click on new, or you can go to the workspace and then create. Okay. Again, same thing, but you will say, hey, I'm not seeing this thing. I will say silver. Perfect. So this is my silver notebook. So as per our fundamentals, what happens in the silver layer? In order to create the silver layer, we perform some kind of transformations. And the very important concept, we apply something called as UPSERT, or the very popular name, or you can say very common name, it is called merge. So we also need to apply merge here in the silver layer. We'll talk about it, how you can just apply merge. It is very simple. Okay. So we need to apply something called as merge. Okay. Makes sense. But what will be the transformations? Now transformations can be anything. First of all, I will just show you the data, the bronze data, which is our source. Select asterisks from data modeling, bronze table. Perfect. Perfect. Initially, it takes just a few seconds because it attaches the new connection with your notebook and blah blah. So this is your source. Okay, bronze table. So now in this, let's say you want to do anything. Let's say any transformations, because transformations can be infinitely long, right? So let's say you want to convert this particular name in the uppercase. Let's say you want to just split this column based on the @ column. Let's say you want to just get the first 5 characters of this particular, not first 5. Let's say you want to just get the domain name based on this particular column. You can do anything, right? So yes, we will perform a basic transformation because we are not actually want to apply transformation, but yeah, just for the, you can say, rules, we need to follow all the rules, right? So let's say in the transformation column, I will okay, let's apply transformation on customer name as we discussed. Let's convert this thing into uppercase because everything is looking clean, but just to apply a transformation. So this is the plan. We will load the data, whatever we have in the bronze layer. We will apply some transformation. Okay. And then we will apply add one more column. It will be called as process date, because in the silver layer, we should always create a column called process date. What it does, it tells us that, hey, this record was actually processed at this particular interval. Hey, this record was updated at this particular interval. So we have to just do that as well. Make sense? So we will be creating those things, and it will be very, very simple. So first of all, we need to create a query. Okay, so that we can just create, you can say, a kind of view on top of it, just to use it as a table, because implementation will be exactly the same. But yes, there are some things that we need to take care of. So I'll simply say select asterisks. Okay, select asterisks from, and let's add one column, customer name upper. Okay, and this columns transformation will look like this: upper and then customer name and then as. Okay, this is our first transformation. The second transformation is I want to apply current timestamp, which is this one, and I will simply say as process date, that at this timestamp, or let's say process timestamp maybe. Yeah, process date is fine. Okay, makes sense. So now this is our, you can say, query that we want to perform. Okay, let's run this. Syntax near. Oh yeah, we do not need a comma. So this is our silver layer, or you can silver tail that we want to create, and this is our process date. Perfect. And we can even convert it into date maybe if we do not want to just use the full timestamp. Up to us, up to our requirements. Make sense? So let's see. Yeah, perfect. Now this is fine. And it's saying, hey, it is processed at 12th of July, and very good. Perfect. So now everything is fine. And we also have that particular column, customer name upper, and very good. So this is the data that we want to write in the silver layer, but it is not that much simple to create the silver layer. Why? Because as I mentioned, we need to apply the merge statement. And in order to apply merge statement, you have to follow some rules. Really? Yes, you have to. So first of all, just tell you one thing. In the merge statement, what you do, you have a destination table. Okay. And destination table, and then you have a source, and you simply apply merge. That means if let's say here we have ID 1, 2, okay, and then 3, and this name is AA, BB, CC, and in the source we have 1, 4, 5, and this name is, let's say, ZZ, this name is DD, this name is EE. So what will happen? 4 and 5 will be added, and 1, this will be updated here because this ID already exists. This is the concept of merge, right? So in order to apply merge, we should have a destination first of all. Obviously, common sense, right? We should have a destination at least, like how we can just take care of all the code. So in that particular scenario, we will use an if condition. Okay, we will use something like this. If, and here, yes, you just need to write one Python code. Very simple if else statement, bro. Come on, you're a data engineer. So if spark.catalog.table exists. So this is a command that tells us, hey, whether this table exists or not. And what is the table name? Obviously the target table name. Target is data modeling dot silver and dot silver table, because this is our table name. Will be our table name, will be. But we are assuming if this table exists, then write our code that we will be writing very soon. Okay. Else, first of all, bro, create our table. Then we will simply say, see, it is giving us suggestions. Then we will write our code to create the table. We will simply say spark.sql and then write your code, create table if not exists. Okay. Create table if not exists, and then let's say your data modeling dot silver table, and you will simply say as select asterisk from silver source, and this is not existing right now. Why? Because we have not created that particular temp view. We will be creating that one. Now one good question can be, hey, if we are using this thing here, create table if not exists, this thing, right? So obviously it will be running just one time. It will not be running next time. So why do we need to treat it in like if else condition? So this, if you write this, okay, if you write this, it will work in the simple scenarios. Okay, but when you just want to apply partitions, when you just you want to just do a lot of things using PySpark code. So this is the standard that we follow, and you should also be familiar with this particular standard. We simply do this. If table doesn't exist, create it. If it does exist, then simply apply the merge code that you'll be just writing very soon. Make sense? Very good, very good. So now I will simply say, this is my command, and let's create silver source first of all. And this is our query, and how we can create silver source. Now you should know, we first need to convert it into Python. Okay. And then we will simply say spark.sql, and then close this, 3 double quotes, and yeah, 3 double quotes. Perfect. So this is my query, and I will simply say dot create or replace temp view, and temp view name will be silver source. Make sense? So this is our source which is ready. Okay, perfect. And this is our code. So if I run this now, it will actually create a table for me. Do you want to see it? Let's see. And now which code is running? This portion. Why? Because this condition is false, right? It doesn't exist. But now if I run this, it will be running if condition. Let me say print. Let's say hey hey. If I just run this, it will give me hey hey. Because now it will be running this one, because now this table is there because we ran this, right? So this table is there, that's it. But now let's create the command for UPSERT, and this is the thing that you need to just learn how to do it. I'll simply say merge. Okay, merge. So in order to create merge, how we create merge, you already know the concept. I just highlighted the concept, how it goes. So you need two things. One is destination, one is source. This is simple, right? So first of all, we create two temporary views, one for destination and one for source. So within this, you will simply say source equals spark.sql. See, it is giving me some suggestions. Wow. But it is not actually correct, like exactly correct. I want to say select asterisk from, this is my source. Okay. Source, by the way, we already have the source, because if you closely observe, this is our source, silver source, right? So I will simply say source equals silver source. So this is my source, which is bringing the new data. Okay. And we can just alias is like this, but it is just source, silver source. Makes sense. Why it is giving me this thing? Silver source. Okay. Makes sense. So we can simply write something like this as well. Select asterisk spark.sql, three things, and select asterisk from silver source. Perfect. This is our source. So our source is ready. By the way, it is giving some suggestions, so ignore. So our source is ready. So now what we need to do, we need to simply apply the merge command. Merge command is very, very simple. Okay, very simple. So in order to apply the merge command, you can simply go to the documentation as well, or just search like merge command. You will actually get the syntax. Merge Databricks, Delta Lake, whatever you want to write. Anything, you will land on the right code. Okay, just scroll down a little bit. And I would say UPSERT, like there are so many documentation, just pick any one. So this is the thing that we just use. Let's say if we want to apply merge command. Okay, so there are two ways, as I just told you, using SQL, using Python. I personally love using Python, but for now I will simply use SQL. Don't worry. Okay, so if you just want to do it like this, you can. Okay, you can. So this way is very compatible with your PySpark code as well. If you want to just apply partitions, if you just want to write PySpark, and usually in the industry as well, you will be using PySpark more if you are using, let's say, kind of big data and all. But yes, SQL, SparkSQL is like equally used. So I'm not saying like people do not use SQL, but yeah, people do use SQL. Okay, so this was a standard that I want you to know about, so that whenever, let's say, you are asked some interview questions related to this, you should be able to answer that as well, because it is related to data modeling, but indirectly. But yes, in interviews, directly related. So now you can actually perform your PySpark UPSERT command. You can say merge command here as well. Okay, so that's how you just do that particular thing. You can say, you can create delta table and just copy and paste, and you will just actually be able to do this, and obviously change the values here, like what is your source, what is your target, and all the things. And if you just want to perform this particular thing, SQL, you actually can just write here pass. That's it. Why? Because obviously we are not using PySpark code, but it's my duty to just tell you all the things which are directly related and indirectly related. Make sense? So this is like using PySpark, merge using PySpark. Okay. Because I don't know, in your interview can ask you some PySpark related questions as well. It is because it is related to data modeling. So I have to just tell you both the things. Hey, this is your silver layer. In the industry, they use PySpark as well, they use SQL as well. So you should be aware of those things, right? So now if you are using merge using SQL, I will simply say merge using SQL. Okay, so first of all we will simply copy this particular code, obviously, because you want to first of all create the table. If it is not there, SQL. Okay, perfect. And let's run this, and it will not do anything because table is there and it will not create it. Now we will simply apply merge command. So merge command is very simple. We simply say merge into, and obviously convert it into SQL. Merge into in which table you want to merge. I want to merge in my target table. The target table is, see, it is giving me some suggestions. It is saying data modeling dot silver table. Make sense? And I want to say using source. What is my source? My source is silver source. Makes sense. Then comes the condition, on which condition you want to apply the merge. So here comes the role of key column. In our case, we have the key column called order ID. I'll simply say on, you can say data modeling. I can also define the alias as well. It makes things easy, but it's not like every time mandatory. Data modeling dot silver table dot order ID equals silver source dot order ID. And now what are these two things? This is your UPSERT. Just observe it. It is saying, hey, when this particular condition is met, then simply update the columns. If this condition doesn't meet, then just insert all the records because those records are new. Make sense? If I run this, obviously what will happen? Nothing, because we do not have any new records. So all the records will be updated. So you will see all the records are updated. Make sense? Very good. So now our silver layer is also ready. Now let's actually try to test our incremental load, because obviously we should see, hey, is our data incrementally loaded with all the merge conditions, with all the things? Okay, let's see and let's actually test it. So I'll simply go to source because we first need to insert some new data in the source. Let's see. So in the source, I will simply write here incremental data. Perfect. Incremental load. And in which table? Again, I just forgot to mention data modeling dot default dot source data. Perfect. Let's insert these new records. Okay. Now these are inserted in the source. Very good. Now in the bronze, it should only and only read the data after the last load date. After what? After the last load date. So now what I'm gonna do, I will be creating a kind of, you can say, if condition here. I told you all the ways from which you can just actually provide this dynamic value, and obviously we have the way to just do it in the notebook as well. Let's do that thing. I will simply say if spark.catalog.table exists. If table exists, which table? Which is our initial data. That means we have created the data. Okay, we have created the table. I will simply say data modeling dot default dot source data. Okay, dot source data. If that table exists, then obviously I know, hey, there is a max date value. That means whenever we loaded the data, I just want to load the data after the max date, after the last loaded date. I will write the code here. For now, I'll simply write pass. Else last load date should be this one. Obviously, because if table is not there, it makes sense that we want to load all the data. But if table is there, last load date will become our spark.sql. Exactly, that's what I want. This is the code. What we want? Spark.sql max of order date. Okay, from data modeling this table. And what is this dot collect 00? This is basically the thing in PySpark from where we just get the first row value, which is the date value. That's it. Now let's actually try to see what is our last load date. Perfect, because we do not need this static solution. Perfect. Let's run both the cells and let's see actually what is the last load date. Perfect. It is saying 2024-07-02. 2027-07-02. Makes sense? This is the last load date, but here we need to say default, not default, bronze. I was like, we haven't loaded this data. So bronze table, bronze table. Perfect. And here as well. Perfect. Let's see. It should return 2024-07-01. Perfect. This is our date, right? Now, if you just run this cell, okay, if you run this cell, what you will see? Let's try to see, hey bro, what is going in our table? Let's first of all confirm that. Silver, or you can say bronze source. You will just see data after that particular date. You will not see all the data. That's the concept of incremental loading. See, just the new records. Just the new records. Very good. Now you will create a table on top of it, and it will replace the table. And because this is a transient layer, perfect. Now we will run our silver notebook. Now what silver notebook will do? It will simply create a view on top of our bronze table. Makes sense? And what is our data? It should be incremental. I will simply say select asterisk from silver source. Let's see. And it should also get just 2 records. Perfect. Now these 2 records will go here, obviously, because obviously this is PySpark code. We are not running this. This was just for the explanation. We will run this cell. What will happen? Nothing, because we already have that table. Now this command will actually be executed, and it will actually, you can say, insert 2 more records. So in the silver table, we should have total 5 records. Okay, let's try to see what do we have. Select asterisk from silver source, not silver source, silver table. And here we can say data modeling dot silver table. Let's see. If everything is right, we should have 5 records. Very good. Because here we want to keep all the data. This is silver layer. This is enriched form of our data, right? Oops. Yeah, this is the enriched form of our data. Perfect. And this is not actually creating duplicates here, because we are using merge command on this order ID. This is the primary key. Perfect. That's how you just develop the silver layer. Make sense? Now it's time to create the gold layer, which is your breaking down this one big table in the form of dimension and fact tables. Okay, now let's quickly talk about what is a dimension table. Like, obviously you know a little bit about of it. Let's talk a little bit in detail before actually start creating dimension and fact table. Let's actually see, hey, how our dimension tables should be created and why, and what should be the qualified columns, right? Because see, this is one big table. This is one big table with all the columns. Now you want to break down these columns in the form of multiple tables so that you can just create a data model. Okay, let's actually try to see a little theory, then obviously pure practical. Okay, let's do it. Now let's first of all talk about the fact table. Okay, obviously there are so many definitions that you can just read, but now let's not talk about just definition. Let's actually try to understand, like, what is that? What is the fact table? So fact table, as the name suggests, it actually stores the facts, and facts rarely change. Okay, facts rarely change. Facts get added like more and more, but facts rarely change. Plus facts are facts. Facts are basically the numbers. Facts are basically the figures. Facts are basically the, you can say, your company's revenue, everything. Make sense? So let's say you have a table, okay, and you have some columns related to, let's say, revenue, let's say cost, profit, sales, or all those numbers, all the numerical terms, all the numbers, figures, all the figures. Let's say any good example, let's say loss. Okay, so these are all the facts of your data, or you can say facts of your particular company. Make sense? So all the columns of the one big table, let's say this is your one big table, all the columns in which you have something called as numbers. It can be anything. Okay, It can be any number. Number means like it should make sense. Number doesn't make like numerical terms. Obviously IDs are also numbers. Those are not like real numbers or figures. So whenever in your one big table you have any columns related to revenue, cost, profit, sales, anything, all are candidates for the fact table. So all those columns go to the fact table so that you can actually take decisions based on those values. You can aggregate those values. You can just do a lot of stuff. All the statistical analysis, all the things. Let's say you are building machine learning model, not you. Let's say data scientist is building machine learning model. He can use a fact table. Makes sense. But if you observe one thing, if I say, if I create a table, okay, and that is a fact table, and there is a column, let's say this one, let's say revenue, okay. If I say, hey, 10, hey, 150, hey, 200, hey, 40, hey, 60, does that make any sense? Does that make any sense? The answer is no. So that means numbers or figures alone cannot fulfill the demand, cannot fulfill the requirements. That's why we have something called as dimension table. So now let's talk about dimension table. This is fine because in this particular fact table you will put all the numbers, all the figures, all the facts, okay, the one thing that you want to aggregate. Okay, now let's talk about the dimension table. What is the dimension table? In short, in very short, dimension tables are the contexts. Okay, context means, let's say you have a data, let's say revenue. Okay, now you want to add a context of region. That means you want to find revenue by region. Okay, that is one context. Let's say you want to add a context to revenue by customers. Okay, so that means you want to now find revenue by each customer, or let's say by group of customers, by their age, anything. But this is a different context. Then you want to add a different context. Let's say this time products. So that means now you want to find the revenue of your organization by products, like which product is performing better, which product is not performing well. All these are context, whatever you want to say. So this is the dimension table. What? This is so simple. Yeah. So every context is a dimension table. This is a separate dimension table. This is a separate dimension table. This is a separate dimension table. So that means whenever your dimension table, or let's say table, just for now table, whenever your table having a bunch of columns, add only one context. Make sense? Because there's a theme of context. Let's say region. Columns can be, let's say, region name, or maybe let's say country, anything. So these are the bunch of columns, right? Make sense? But theme is region. Just focus on the theme. Theme is region. Similarly, in the customers table, you can have customer ID, name, age, blah, blah, blah. But theme is customers. That means all these columns are actually adding the same context. All these columns are adding actually the same context. These columns can be, let's say, prod ID, category, subcategory. Make sense? So all these columns are adding the same context. So every time when you group some columns and when you feel, hey, these columns are adding one theme, hey, these columns are adding one theme, hey, these columns are adding one theme, that is your dimension table. Simple. So now you can add so many context to your fact table. Similarly, you have, let's say, another column. Let's say you have profit, right? Same thing. You can just do this as well, like profit. Same, these context, profit by region, customers, products, and these are the columns. Make sense? So you actually add a theme of context using so many similar columns. That's the easiest definition. I do not like to just read the definitions written in the books. Yes, they are really, really good. But if you are understanding something, you need something extra than that. Okay. If you want to actually understand that. Okay. So now I hope fact and dimension table concept is clear. Okay. Forget about normalization, one normal form, second normal form. No. You are a data engineer. You need to build a dimension data model. Just stick with this. That's it. That's it. Make sense? So now let's actually try to see how we can just create this particular data model in real, because that's the most important thing, right? Okay. And yes, there will be some new terms, something called as surrogate keys and all those things. We will just talk about at that time, because that particular term, those particular terms will make more sense if we discuss in the practical things. Okay. So let's actually see how we can just build dimension fact table. So I am in my notebook. Okay. So now what I will do, I will simply create a new notebook. I will say gold. Okay, let's rename it quickly. Perfect. Let me just connect this notebook to the cluster. And let me check my voice is being recorded, because sometimes I just forget it. Okay, so now what we need to do, we know that our source is silver table and that is ready. And let me just have a quick look. Select asterisks from data modeling dot silver table. Perfect. And just an FYI, that means for your information, we always start with dimension tables, and fact table is our end table that we create at the end. Okay, makes sense? Very good. Very good, very good, very good. And we know that our data has a theme of sales, main theme. I'm not talking about inner themes for dimensions. No, main theme. We are building a sales data warehouse, the main theme, okay, or parent theme. Make sense? Perfect. See, or you can say orders, not sales, or you can say orders. But I think orders and sales are like same thing. So we have the main theme of sales. Okay. And within this, we have so many themes, customers, regions, products, and blah, 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 blah. Make sense? Okay, very good. So now what we need to do, this main theme, or you can say this main data warehouse theme, which is sales, we need to create fact table and dimension table. Okay. Fact table will be having all the numbers, let's say amount, sales, and all those things. Yes. And we will create that at the end. And that is the rule. We always create fact table at the end. You will know the reason as well. Don't worry. So first of all, let's try to start with our dimension table. Now in this one big table, you need to find the theme, like which theme you want to pick. Okay. Let's try to have a look at the columns. Okay. So we have order ID. Okay. We have order date. Okay. Then we have customer ID. Oh, nice. Customer name. Okay. Customer email. Okay. These three things, these three columns are actually serving the same theme. If you observe, makes sense. Okay. Then do we have anything similar to customer? Because let's focus on just first dimension first of all. Okay. No. Oh yeah, we have customer name upper. Very good. So these four columns are actually serving the same purpose. Make sense? Okay. So now what I will do, I will create a dimension table on top of these four columns. But in order to do that, we also need to take care of the primary key of the column. Because what will be the primary key? What will be the primary key? The primary key will be this one for the dimension table, customer ID. Make sense? Because this primary key of the dimension table is acting as a foreign key in the main table. And you should know the concept of primary key and foreign key. Primary key is just like the unique identifier, plus it follows all the rules that it cannot be null and all those things. Plus foreign key is just like the primary key of the table is being used to apply the join in your main table. Okay. Fundamentals of primary key and foreign key. Make sense? Okay, very good. So now what we need to do, actually, we will simply say select, if I say select customer ID, okay, customer email, okay, then customer name, then customer name upper. Okay, these are the four columns that I want from this particular table. Let me just try to run this. because this is my dimension. Perfect. But we have some duplicates. Here are the duplicates. So these were not actually the duplicates in the orders table. Why? Because orders table is storing the orders information. One customer can create 2 orders, right? But in the customer ID, how can you just store the same customer 2 times? So now you need to remove the duplicates. Make sense? Because see, in orders table, it makes sense. Okay, one customer came and placed the order, same customer came and placed the order again. Makes sense. But in the customer's data, in customer's table, we are storing all the customers information, all the unique customers. You are saying, hey, any name, any name you want to pick. Okay, if I will pick boy's name, you will say, hey, you don't pick girl's name. If I will pick girl's name, you will say, hey, you do not pick boy's name. So let's say XYZ. Okay, there's a customer called XYZ. So this is the information. You will say, I will store this information 2 times because this customer placed the order 2 times. No, bro, no. We do not do that thing. So we need to simply remove the duplicate. So I will simply say distinct. Okay, just say distinct customer ID. So what it will do, it will simply pick the distinct customer IDs. Okay, makes sense. Or you can say distinct customer email, because this can also be the, you can say, good candidate for primary key, because one person cannot have, or let's say 2 persons cannot have the same email ID. I will now run this. It will remove the duplicates. Yes, perfect. 1, 2, 3, 4. Perfect. That's what we want in our dimension table. But we need something else as well. What is that? It is called surrogate key. What is surrogate key? See, wow, good handwriting, Ansh. Surrogate key. Okay. What is surrogate key? Surrogate key is nothing but your normal counting that starts from 1, 2, 3, 4. What is the purpose? So see, here we have customer ID with simple name 1, 2, 3, 4. That is fine. But usually in the real world, this customer ID will look like this. Blah, 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 blah. So if we want to apply join on these columns, it actually affects the performance. Plus, it is not ideal to just keep on doing this thing. Why? Because here only one column is the candidate of the primary key, or you can say only one column is the primary key. But sometimes in some dimensions, more than one column is like primary key is behaving as a primary key, and that's called composite key. So obviously you do not want to involve so many columns in the join. So what we do, we simply say, hey, what is your primary key? I will say, hey, this is my primary key. Okay, I will generate simple number 1 for this identifier, 2 for this identifier, 3 for this identifier. Now just use me 1, 2, 3, 4. That's it. That's how you perform surrogate keys. So whenever we will be creating dimension tables like this, we will always create surrogate key as well. So whenever we want to join this dimension with fact table, remember we always you can say add context to the fact table, obviously using join. So we will use surrogate key instead of this customer ID. That's the rule of data warehousing. Make sense? These are some advanced things, not advanced, I would say deep things, not advanced, like deep, and you need to go in deep. Okay, so now what you need to do, you will simply say row number. That's a window function in SQL. If you do not know about that, it's just like a row level function. Row number, I will say over, and then I will say order by on customer ID. Make sense? You can just put order by on any column, because all are because row number will not produce same number 2 times. So row number is chill. So I will say customer ID. Perfect. I will say dim customer key. Okay, that's the standard that we use. Dim and then dimension name and then key. Let's try to now run this. Wow, error. Obviously we need to put this before. Obviously, common sense. Let's run this. Perfect. So now we have dim customer key. See, and what actually happened here? Just try to see. Here you have something called as distinct 1, 1, 2, 3, 4. But do you know what happened? Row number always produces a unique number for all the customers. So here in this particular case, what happened? We removed duplicates. We know that using distinct, but it actually applied row number along with that. And that's the cause of this thing. So it is treating this number as a different key, this number as a different key. So we do not need to apply this. So that's a very common mistake that you can also perform. So what's the step? What's the solution for this? You get a solution step for this. So just remove this step from here. You will create surrogate key after you can say eliminating the duplicates. That's the rule. Just note it down. Do not apply row number along with duplicates. No, it will break the dimension, because once you have a duplicate dimension, bro, your dimension is broken. I will simply say select asterisk. Along with this, I will say row number over, and then order by. Okay, order by customer ID. Customer ID, and I will simply say dim customer key. Make sense? Now it is not simple. You need to say from which? From this thing, from this table. This is a concept of subquery in SQL. That's why we say, hey, SQL is very important. So this is just a subquery. So what is happening? First of all, we are creating this query which will remove the duplicates. Then we will add a column after removing the steps. You can also use CTE if you are familiar with CTE. I will just show you first of all from this way, because some people like using subqueries, some people like using CTE. So it's a personal choice. So now it is acting normally. See, 1, 2, 3, 4, 1, 2, 3, 4. Obviously, it's a coincidence we have 1, 2, 3, 4 here as well. But I just told you it can be having, you can say, a long number, but it will simply give you a simple 1, 2, 3, 4. Make sense? And now let's talk about with CTEs, because I don't want to hurt anyone. I will simply say with, you can say remove duplicates. This is a kind of thing that you do, right? Then I'll say as, and then you can write here, select asterisk from remove dup. Okay, and along with that you will add row number over order by customer ID, and I will simply say as dim customer key. Perfect. Let's try to run this, and it should produce the same result, because this is a concept that we use with CTEs. So what it does, it simply stores this data, this query result basically in this particular variable. Make sense? So that's how you can actually use this particular thing. See, remove dup in this particular cell. Make sense? This is just like basics of CTEs, common table expression. So now our first dimension is ready. Okay, and similarly we need to create different dimensions, and I will simply add one heading here so that you can actually refer it for your notes. I'll simply say dim customers. Okay, perfect. So now this dimension is ready. Now we just need to create a table on top of it, and we already know how we can just do that. I will simply say create or replace table. Okay, and we are just creating a table for full load. Make sense? Like whatever data do we have in silver layer, we can actually just perform, like you can say, pull all the data into the gold layer every time. Make sense? Okay. Yes, in the industry as well, we just perform incremental loading on the silver layer as well. But now you're familiar with silver layer, how we perform incremental loading. With the course of time, you can actually understand how you can perform incremental loading on table as well. See, it's simple. Instead of using initial load, you will simply add a timestamp, and you will perform greater than thing, and you will simply prune the query, and you will get the data greater than that particular date. You already know that. But yes, we are currently focusing on dimension and fact tables. So we need to understand how we can create dimension and fact table. Make sense? Okay, good. So it will say create or replace table. I'll simply say data modeling dot gold dot dim customers. Make sense? And then as. Okay. Then as, and yeah, let's create a query. So okay, this is done. Our dim customers table is done. Now let's see our next dimension, and let's go to our silver notebook just to see like what is our next context, next theme of context. So next theme of context is, let's say, okay, customers is done. Now I can see product ID. Okay, so let's talk about product ID. I can see product ID, product name, product category. These columns are serving the same theme of context, which is, you can say, products, dim products. This is the best candidate of the dimension called dim products, and in that we can store product ID, product name, product category. Make sense? Make sense? Make sense. Okay, so now do we have anything else? I don't think so. No. So I will simply create dim products. And what are the column names? Product ID, product name, and product category. Very good. So let's try to query the data first of all. I will say h3 bold dim products. Okay, I will say select SQL. So product ID, product ID, product name, product category. Make sense? From data modeling silver table. Makes sense. Let's run this, and we should only see the columns, which is our theme of products. Perfect. Do we have any kind of duplicates? Yes, we do have any kind of duplicates. So this product was ordered 2 times. And obviously one person can order this shoes 2 times, or any person can order this product 2 times. Let's say me and you both ordered this pair of shoes. So obviously this will be create a duplicate. So same thing we need to do it here as well. So I will simply say distinct. Make sense? Distinct product ID. Let's try to run this now. Perfect. Now we have unique pair of, not pair of shoes. So I was just like, oh wow. So we have unique product IDs, or you can say unique records for each product, and each product ID is associated with a name, obviously, and category can be obviously you can say redundant, because this is also electronics, this is also electronics. Make sense? Very good. Very good. Okay, and we will talk about a very good topic. It's called Snowflake schema. Okay, so don't worry, we are not talking about any schema. We are simply building dimensional data model. Yes, we will break it down further into star schema, Snowflake schema, everything. Don't worry. Okay, first you need to build it, then only you can understand the things. So I will simply add a dimension surrogate key. As you know, we add it every time. So I will simply copy the code from here, and I will insert it here, and I will replace this code here. Okay, and then I can say dim products, and this will be product ID. Okay, and this will be dim product key. Make sense? Let's run this, and let's actually try to see how our table looks like. Gold dim products. Now we have 2 tables, 2 dimension tables. We have created both the tables. Okay, so perfect. We have like 1 2 3 4. See, it will only generate 1 2 3 4. It doesn't care about your this. It will just generate 1 2 3 4 based on the rows. That's it. But it's your duty to make rows deduplicated. Okay, it should not contain duplicates, otherwise it will be a mess. Okay, makes sense. So we have created our second dimension as well. Let's see the other dimension if we can create. The third dimension is payment. Okay, payment type and country. Okay, we can create actually two more dimensions. One is for payment and second one is for country. But yeah, it will be having just two columns, but that is fine because both are serving two different themes. This is related to payment. This is related to region, right? So I will simply say dim payments. Let's create it quickly. So I will simply say text h3 bold and dim payments. Makes sense. I will say payment mode from data modeling .silver table. What is the column name? Payment type. Okay, so payment type is here, and obviously this is duplicated, and we just have two different kinds of payment, credit card and PayPal. That means we need to deduplicate it. Same thing, you already know. I will write distinct payment type, and I will add with CT as well. Let's say remove duplicates as this one. I will say select asterisk and row number. Perfect. Dim payment type key, not payment type key. I think dim payment is fine. Dim payment key, because this dimension name will be dim payments, and I will quickly create the table on top of it. Create or replace table. And then data modeling goal dim payments. Perfect. Let's run this command and let's see how a table looks like. Wow, error. What happened? Okay, makes sense. Who told you Ansh to enter this? Okay, perfect. So I will simply say select asterisk from data modeling girl and dim products. Where is our dim payments? Let me run this. Okay, perfect. Our dim payment is also ready. Let's quickly copy this code and let's create our last dimension, which is region. Make sense? Because this is the region which is giving us the some context for in which country the order was placed, right? US, Canada. So I will simply say text h3 bold and dim region. Let's do this, and here we just have country, and it will be again country. It will become dim region key, and it will become dim regions, right? So perfect. Let's try to see this as well. Select asterisk from data modeling gold dim regions. Okay, our all the dimensions are ready, and you can see every dimension is deduplicated, has a specific dimension key, and everything is there. Now you do know what do we need to do? We need to create one more dimension. Ansh, come on man, just see, we do not have any columns, we don't have any themes. See, we do not have anything. You are right, actually you are right. But so I told you that each dimension will act as a theme. We have a theme for customer, we have a theme for product, we have a theme for regions, we have a theme for payments. Where is the theme of sales? What does it mean? Where is the theme of the whole table? So this is a thing that you will learn when you will be actually entering into the industry. Yes, we break down the table into multiple like so many multiple dimensions, but at the same time we create one big dimension for the original theme as well. Because see, customer is a theme, product is a theme, payment is a theme, country is a theme. But this is also a theme called orders, or you can say sales. Make sense? In which we will store all the information. We will store order ID, order date, customer ID, customer name, customer email, product ID, product name, product category, obviously not quantity, and then payment type, country, and last updated we can save. It's up to us. Yes, we will save it. Then customer name upper and process it. Everything except quantity and unit price. Everything, because this is the theme of the entire table. We need the dimension for the entire table as well, because our model will look like this. Let's say this is the fact table, right? If it needs a theme of customers, we have. If it needs products, we have. Regions, we have. And let's say we need theme for country, or not country, payment, we have. But it wants to also get the theme of its own theme as well, like the parent theme, sales. Who will provide that? The main dimension that we're gonna prepare right now. Make sense? So now this is our last theme, and we create this dimension at the end. This is dim sales, which will be giving theme for the orders, which will say, hey, this order actually generated this much of amount. Hey, this order actually generated this much of amount, like this. Make sense? So we'll simply say select all the tables, like all the columns, but except those columns. So I can go to here. I can say I just need to get the columns. That's it. So what I can do, I can play smart, because I don't want to write all the columns. I will simply say SparkSQL select asterisk from silver table. Don't worry, this is just a step for bringing the column names. Dot columns. Dot silvers. Wow, silvers. Okay. That's how you can play smart. So now I will simply say select asterisk, not asterisk, these columns. And I do not want only two columns, quantity and unit price, because these are there in the fact table. From data modeling dot silver table. Okay. Now if we run this, we will simply see only those tables. Make sense? Make sense. And in this particular thing, oh, it is simply adding this thing. I don't like this single quotes, man. Let's remove this. It will not create any problem, but you know, I'm a fan of UI and those things. Those small things I do like a lot. So perfect. Now this is very good. So now you do not need to perform that deduplicated step. Why? Because every record is unique. Because this is just coming from the main table. Okay. But yes, ideally some people perform this particular, you can say, guardrail, but we do not need to apply that because we know like every record is unique. Okay. Makes sense. But yeah, you can do that if you want. So let's create a row number. Okay. Let's create a row number here. I will say row number over fact sales key. There's not a fact sales key. It's a dim sales key. Dim sale key. Dim sale key. Okay. So let's see how does it look like. We have a dimension for each order, and obviously you would have placed so many orders. So you see like order IDs are so long. So we have simple cute little number 1 2 3 4. I will now create a table on top of this. Create or replace table and table name. data modeling, gold, and dim sales. Perfect. And as let's run this. Let's run this. Okay. Oh, so quick question. You can either use as here as well. So it works without as well. It works with as well. Okay. Create or replace table and then as. Then let's try to query the data. Select asterisk from data modeling dot gold dot dim sales. Let's see if we have that particular dimension or not. Yes, we have. Very good. Very good. So now we have all the dimensions ready. Now it's time to actually create the fact table. How we can create fact table? So in the fact table, as I just mentioned, we will just need these two columns and that's it. Which two columns? All the numeric columns. So quantity and unit price. That's it. We do not need anything else. Nothing bro, nothing. Just these two columns plus all the dimension keys. Because obviously we need to just apply a model. We need to just apply joins to build a model, right? So I will simply say my fact table will look like this, and fact table creation is very simple. Just join, simple join, that's it. This is the easiest step in the dimensional data model. I will simply say fact table. Okay, very good. Fact table. So what do I need in fact table? I need select what were the column names? Unit price and quantity. Okay. I want quantity. Okay. I want unit price. Yes. And I want dim customers key, or you can say customer key. I want dim product key. Okay. I want dim region key. I want dim payment key. And I want dim sales key as well, or you can say sale key. Sale or sales? Sale or sales? Sale. Yeah, good. From obviously data modeling dot silver. Yes, obviously, because these two columns are in silver, right? Yes, we will simply call it as, let's say, F, because this is the source for fact table. So I'll simply add F dot okay. Then I will, oops, who ran this cell? Who? Ansh Lamba. I just hit shift plus enter by mistake. I will say left join, and left join with Databricks gold dot dimension, like gold, not silver, because our dimension is in the gold schema. Make sense? I will simply say data modeling dot gold dot dim. Let's apply with customers first of all. I will give the alias at C. Okay, and I will simply say C dot dim customers key. Make sense? Very good. What's the joining condition? Joining condition is F dot customer key, customer ID equals your C dot customer ID. Make sense? Because that is the joining key, right? Exactly. That is the joining key. So after applying the join, we are actually pulling the dimension key. Make sense? Because once we have applied the join, we just need the key for it. We do not need any other column. Just store all the information, all the context within your dimension table. We just need a key. So that means whenever I want to add a context, I can simply apply the join and I can simply get the context. Usually these joins will be applied on the BI level. What is BI level? BI level means your reporting level. Make sense? So that they can just build their model to present the data, or it can be used by data analyst, or it can be used by data scientist. Our work is to just to create the data model and just present it. That's it. Whatever they want to do, they can. Okay. So being a data engineer, just say, hey, this is our data warehouse. This is our data model. Use it, throw it, do whatever you want to do. It's your concern. So now this is done. Let's say left join with P On product ID, yes, it is giving me some suggestions. Very good. That's what I like about this particular engine. Dim regions and dim payments. Yes. Oh, we forgot to bring payment. No, we have. So we have 1, 2, 3, 4. 4. We should have 5, right? Which one is missing? Product key is there, region key is there, payment key is there, sale key is there, customer key is there. Oh, 1, 2, 3, 4, 5. Yeah, perfect. So this is S dot. Do we have sale? No, we will just create it. Dim product key is P. Dim region key is R. And dim product key is P. This is payment, right? So payment, where is payment? Payment is PY. Very good. It is actually handling those things. Very, very good. So C is done. Everything is done. And only S is left. So now I will say on F dot payment type equals this. Yes. Last is left join. Data modeling dot goal dot dim sales on order ID. Very good. See, it has suggested many join conditions, saved a lot of time. So let's actually try to see how our data looks like now. Okay, and it should perfect, man, perfect. So in our data, we just have dim, and just 2 numerical columns. That's what we want. And your fact table should only and only contain numeric columns plus keys. That's it. There should not be any date. There should not be, like, I'm not talking about process date. I'm talking about order date. Okay, because obviously you can add one process date just for the flag, like when this record was added or updated. That is something else. I'm talking about any order date, any cancel date, any ID, nothing, just neat and clean. This is your fact table. This is your fact table. Make sense? Now let's create a table on top of it quickly. Then we can say, hey, our data model is ready. And then we need to just talk about some advanced things. Not advanced things, some like things in detail. There are some dependencies, there are some additions that we need to talk about. Okay. Create or replace table. And then I can say as. Perfect. So our table is also ready. So let's say select asterisk from data modeling goal dot fact sales. Okay. Perfect. Our data model is ready. If you just click on this catalog in the data modeling part in the gold layer, you will see all the dimension and fact tables. This is your data model. This is your dimensional data model, or you can say data model that data engineers built. Data engineers built data models like this. And we have dimensions this, and this is the whole dimension, which is just giving a context of the original theme, the parent theme, to this fact table. Make sense? Yes. Now let's talk about a very popular concept called star schema versus Snowflake schema. Why I didn't discuss this before? Because I want you to build the schema first, then you need to understand what is star schema and Snowflake schema. And the good thing is you have already created the star schema. So this was the star schema. Really? Yes. So what is the star schema? Let's talk here. So let's say this is your fact table. Okay. You have 5 dimensions. 1, 2, 3, 4, 5. Make sense? So when you have fact table and all the dimensions connected one-on-one means like directly, not like 1:1 relationship. We are not talking about relationships, just connection, like direct connection. So see, if you observe, this is connected to this, 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 this is connected to this. So this is called star schema, and this actually assembles the shape of star. How? You can just draw star like this. Oops, my drawing, man. Let me just use a different marker. Let's say this one. Let's use pink color. This, and this. This is a star schema. Now you will say, hey, this was so easy. Exactly. If I would have told you star schema, Snowflake schema before, you would be like, off, like, oh man, what is this? So this is so simple. This is your star schema. That's it. Now, what is Snowflake schema? Just a disclaimer, in the real world, in the real industry, companies rarely create Snowflake schemas because it is very hard to maintain those schemas. Okay, those data models. We just stick with star schema as much as we can, but yes, in 1% chance, you will be just creating Snowflake schema. But do you know what? Companies rarely create Snowflake schemas, but Snowflake schema questions are the favorite questions of the interviewers. I don't know why. I don't think so. They have themselves have created Snowflake schemas or not, but it is a very popular question. Hey, what is Snowflake schema? Hey, how it is different from star schema? Hey. So let me just tell you what's that. So basically, Snowflake schema is the extended version of star schema. Sometimes we get some dimensions in which we have to extend it. What does it mean? So let's say this is the dimension. Let's say this is the, let's use orange color. This is the dimension. Okay. This is the dimension, and this is dimension related to, let's say, products. Okay. This is giving you the products theme. Makes sense. Now in this particular products, we have product ID, product name, product, you can say weight, product, all the things. Okay, all the product things. But when you have this product thing, you have category, you have subcategory. Obviously we do not have subcategory, but imagine you have subcategory, you have subcategory weight, you have category weight, you have that. So this table is actually becoming big and big. So in that particular scenario, you create a small dimension from this. And this is connected to this fact table, but indirectly, because there's no connection between this fact table and this dimension table. No, but this is connected through this products table, product dimension table, and this dim products dimension table is connected to the fact table. This is the concept of Snowflake schema. When you extend your dimension, a very good example, let me just show you. So if you observe your products dimension, where is that? Yeah, perfect. So now if you observe closely, you can actually create a dim category as well, because it is redundant here. And you can say, hey, I will just bring the dim category ID, let's say dim category key, let's say 1 and 2, 1, instead of just writing this thing, and this thing will be replicated here in the table in a separate dimension table. Make sense? If you want to extend this, usually we do not extend that because it affects the performance as well, because you will be applying multiple joins. Second, it is very hard to maintain. Make sense? But yeah, this is the concept. So this way you can actually create a different mini theme, because this is the parent theme product. You will say, hey, I can create a different theme called category, like inner theme or smaller theme, extended theme. Make sense? That's how you create the Snowflake schema. This is the concept of star schema and Snowflake schema. That's it. Was it difficult? Now not. Earlier it would be, but now it is not, right? So this is the concept of star schema and Snowflake schema. Now we need to discuss some, you can say, types of dimension tables and types of fact tables, because those are the things that you should be aware of. Plus those are the bread and butter in your interviews as well. So within this video, I want you to be prepared for interviews as well. You will be a pro data modeler. You will be prepared for interviews as well. So everything in one place. Okay. So let's try to cover those concepts. What are those things? Let's try to talk about types of fact tables. Yes, we do have types of fact tables as well. And let me just tell you what are the types of fact tables. So first of all, the very basic and the most widely used fact table type is transactional fact table. What is transactional fact table? Or you can say there's another popular name, but this is like, I think you can use it. This is, you can say, the default fact table. Why default? Because usually in the fact tables, one row is equivalent to one transaction, and it is like the most granular version of fact table. Make sense? Most granular, in which you have the fact tables, okay, in which you have, let's say this is a fact table, these are all the rows. So in this, each row is actually representing an independent transaction. Make sense? And this is a fact table that you have just built. This is a fact table that you will be building most of the times. But yeah, we have other two types as well that you should know. And let me just tell you, from the practical perspective, transactional fact table is like your go-to type of fact tables. But obviously in the interviews, they do like asking some conceptual things because these are really, really important. Okay. The next type is very popular in the interviews. It's called periodic fact table. What is periodic fact table? So when we talk about periodic fact table, as the name suggests, it actually represents a period. Instead of just one transaction, it will present a bunch of transactions and each row will represent a period. Let's say you have a fact table. Okay, so the granularity of this particular table will not be like, you can say, dependent on the values of, you can say, of your, let's say, order ID or any kind of those key columns. Here your each row will be aggregated based on, let's say, week, maybe month, maybe year, maybe day. So it depends. But this will be the aggregated version of your fact table, in which you will say, hey, these are the details for this week. These are the details for this week. These are the details for this week. So each row will represent a period instead of just all the granular values. No. Periodic fact table means aggregated fact table. Make sense? Okay, let's talk about the third type of fact table. It is called accumulating fact table. What is accumulating fact table? So basically accumulating fact table is actually, how can I say that? So basically it describes the journey. Okay, it describes the journey of a transaction, or you can say of a product, of anything. For example, or let's say of something, it describes the journey of something, whatever the fact table is built on. So let's say you are building a fact table for order. So this fact table will look like this. Hey, this order was placed at this interval XYZ. Then this order was in transit at this time. This order actually entered the warehouse at this time. This product left the warehouse at this time. This product was on its way to the customer at this timestamp. This product actually was received by the customer at this timestamp. So basically this fact table, this type of fact table actually describes a journey, like how your order was created, and it will say at this timestamp, this was here at this timestamp, this was here at this timestamp, this was here. So when you see a lot of dates in your fact table, that can be called as accumulating fact tables, because accumulating fact tables will tell you the journey of something. That's why you see a lot of dates in some kind of fact tables. And I would say a very potential use case for these kinds of fact tables will be for the delivery, you can say, organizations, where they need to just track a lot of things, right? When the order was placed and blah, 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 blah. So these are the common types of fact tables that you should know. And obviously from the concept perspective, it is really, really important. From the practical perspective, you are good. You have already built the fact table. Okay. So now let's talk about the types of dimensions. Oh, we have types of dimensions as well. Yes, dimensions. Yes, we have. First of all, let's talk about very popular type of dimension, conform dimension. Say you can be tricked in the interviews after hearing this word conform dimension, because sometimes you cannot remember it, because other dimensions have some meanings, other fact tables have some meanings associated with the name, but you can be confused when you will be saying, hey, what are like conform dimensions? So basically the concept is very simple, but you can forget. Okay, so just keep this in your mind while sitting in the interviews. So conform dimensions means, let's say this is your fact table. Okay, this is your fact table 1. Okay, this is a fact table 2. Make sense? Let's say this is order, this is cancelled orders, anything. Then we have one dimension. It's called products. Now, obviously, if I have fact table for orders, I will be connecting this thing with the products table, which is dimension. Then I have a fact table for cancelled orders. Obviously, I will connect this with products as well because I want to see which products are being cancelled more. So this particular dimension is now called as conform dimension because this dimension is connected to 2 different fact tables. It can be 2, it can be 3, it can be more than 1. Okay, so these types of dimensions are called conform dimensions. Make sense? You will remember it, right? Good. So now let's talk about something called as degenerate dimensions. Degenerate dimensions. Now what are degenerate dimensions? So in these kinds of dimension tables, you do not see any kind of associated value. For example, in your one big table, okay, you have one column called customer ID. Okay, you have this column, but you do not have any kind of customer name, you do not have any kind of customer age, height, weight, anything. You just have this ID. You just have this ID, right? What you will do with this ID? What you will do? Yes, you can create customer ID dimension separately, but you will just get the customer ID, right? So these kinds of dimensions when you create is called degenerate dimensions because it just has the information for ID, but nothing else. Yes, it is adding a context to the fact table, but you do not actually have the related information for customer ID. So these are the things that are called degenerate dimensions. Okay. Now let's talk about our third type, which is chunk dimensions. Now what are chunk dimensions? So we say chunk dimensions when in our dimension table we just have 1 or 2 values basically. Oh, very good example. In our dimension that we just created, one was payments, dim payments. How many values did we have in that particular dimension? Only 2, credit card and PayPal, right? So those are called as chunk dimensions because we just have 2 records in those dimensions, right? We do not have like a lot of records. So those are simply chunk. Yes, chunk, not actually junk. They are helpful, but they are called as chunk dimensions. Okay. Now let's talk about a very important dimension, and it is called role playing dimensions. Okay. Now what are role playing dimensions? Let's say you have a dimension, and usually it goes very well with date dimensions. Let's say you have created one dimension called date dimension and you kept this name as, let's say, dim date. Okay. So in this you have date, obviously, and then you have, let's say, day, year, month, blah, blah, blah. Now let's say you have the fact table. Okay. You have the fact table. Here you have 2 different kinds of date. One is order date. Okay. Other is cancel date. Okay. So initially you connected this table. Okay. You connected this table on the order date column. This one. Make sense? So this is the main relationship, or you can say main kind of join that you are applying to connect this dimension with this fact table. Make sense? Okay. Now at the same time, it can play another role as well. What is that another role? So let's say this cancel date, this one, is also connected to this dimension, but this is not an active relationship. This is inactive. Make sense? This is inactive relationship. So This dimension is actually playing two roles, one for order date, one for cancel date. So these kinds of dimensions are called as role playing dimensions. Yes, they can be only one active relationship at a time, but it can be switched. It can be switched if you want to switch. Make sense? So this is your role playing dimensions. Very good. Now I forgot to mention one important type of fact table, which is called factless fact table, and it is very popular. You will say, what is this factless fact table? So what are factless fact table? Any guesses? So when in your table, okay, you do not have any type of numeric column, you just have IDs, you just have date, you just have all the things, but except the, you can say, numeric columns. So obviously we will aggregate. Okay, so we just call those tables as factless fact tables. Make sense? So this was missing. So I thought like just share this as well. So these are the types of fact tables and dimension tables that you should know. And yes, these are very much important from the concept perspective. And obviously when you sit in the interviews, there is a very important topic which is equally important from concept perspective plus the practical perspective as well. And this is called slowly changing dimensions. Do not worry. I know this is a very, very, very hyped concept and you will be thinking, hey, this will be a complex one. No, it will be very easy. Let me just tell you what are slowly changing dimensions and how we can create slowly changing dimensions with the help of code. Let me just show you. So let's talk about the slowly changing dimensions. What is this concept? First of all, Ansh, Lamba, tell us this thing. Basically, whenever we create dimensions, see in our this particular course as well, we created 5 different dimensions. But you know what? Dimensions do change with the time. And it makes sense. Obviously, let's take an example of this particular table, which is products dimension. Let's say this is a dimension called products dimension. So currently your organization has product ID 1 and the name of the product is honey. Then 2, this is shirt. Then 3, this is com. In future, let's say they change the category of this particular product and they just put it, let's say, merchandise. Okay. Let's say maybe they just change the name of this honey. They just added pure honey, 100% pure honey, extracted from, I don't know. So that's how they can just make those changes, and they usually make those changes because obviously you need to evolve your data with the time. And I'm not talking about they're evolving the facts. No, I'm just talking about they're evolving the data, like the dimensions data. So it needs to be updated with the time. Makes sense. Very good. So this is the concept of slowly changing dimension. They do not change rapidly. They change slowly. Let's say you are creating one dimension. Maybe that dimension will be changed after a month. Maybe let's say after a week. So they do not like rapidly change in every iteration. No, they slowly change. Okay. So now in order to tackle with these scenarios, slowly changing dimensions, we have actually divided this whole area into 3 different parts. Or you can say 3 different types. One type is slowly changing dimension type 1. Let's talk about this first of all. So slowly changing dimension type 1 is called SCD type 1, or the very popular name is UPSERT. Yes, this is the UPSERT that you have already applied, but there are some things that you need to add, but the rest of the stuff are already the same and you have already done that. So that is the best thing about SCD type 1, and SCD type 1 is the easiest way to tackle slowly changing dimensions. And I would say in most of the cases, organizations use SCD type 1. Yes, they use SCD type 2 as well, but they use SCD type 1 more than SCD type 2. Okay, what is SCD type 2? We're not going to look at right now. So for now, let's focus on SCD type 1. So as I just mentioned, let's say this product category is changed, right? So now it is here. So do you know what? If we have SCD type 1, we will simply replace this value with the latest value. That means update. And if we will be getting any new product, it will simply insert the value. Now you are very much familiar with UPSERT, so I do not need to discuss UPSERT in detail, but yeah, this is the same concept. of slowly changing dimension type 1. In this, we do not maintain any history. In this, we do not actually track any changes. We simply update the values with the latest values. Make sense? Very good. Now let's actually try to look at this thing using code, using examples, and let's see how we can actually create those things. Make sense? Very good. So let's go to the Databricks workspace. I am in my Databricks workspace, so it is saying disconnected. Let's connect it. And before that, I will create a new notebook and I will name it as SCDs. And don't worry, I will provide all these notebooks, so just enjoy. So I will say SCDs. Okay, let's connect it. So for now, this is totally an independent topic and we are going to just focus on the slowly changing dimension part. So let's create a new source so that you can actually understand it from the slowly changing dimensions perspective. Okay. So first of all, let's create a table quickly. I will say create table and this will be called as, let's say, data modeling dot default dot, I will say SCD type 1 source. Okay, this is my table name and I will simply say prod ID. Let's create the same example so that you can understand. Product ID, it will be integer, and then let's say you have product name. Yep, let's keep product name, that's it. And let's say product category as well. Yep, product category string, and I will add one more column which is process date. You know that we always add process date, right? Date. Perfect. So let's create this table and let me just write the code to insert the values, insert into this table. Perfect. Now values. So values will be, let's say 1, then prod 1 cat 1 and current date. Perfect. Let's say prod 2 cat 2 current date. Let's add prod 3 cat 3 current date. That's it. We just need to insert these 3 records for now. Okay, let's do that. I will give the heading here SCD type 1. Okay, perfect. So this is inserting our data and we know it will insert it. So now let's say we want to create a slowly changing dimension on top of it. So what we will do, we will simply apply the merge command. Okay, and for that we just need a source, right? So our source will be look like this, or obviously we should have a target table. So let's quickly create a target table as well. So I will simply say create table in the gold layer. Okay, data modeling dot gold dot SCD type 1 table. Okay, within this we will create prod ID, prod cat, and we will create process date as well. Yeah, make sense? Process date, and this will be my date. Okay, perfect. So this is my target. Make sense? Very good. So now this is the thing that we need to use. Okay, so this is our target, this is our source. Let's apply merge command, and merge command is very easy. Merge into and convert into SQL. So merge into, we need to merge our data in this particular table. This is our slowly changing dimension table. Merge into this, and then using source, and source is, we need to create a source. I will simply say source equals spark.sql, select asterisk from data modeling dot default dot SCD type 1 source. Perfect. So this is my source, and actually I can create a view on top of it just to keep everything same, and this is, let's say, my source. Okay, so I'll simply say source, and I can also use alias here as well as say target trg. So this is the thing using source. Okay, now what we need to do, we need to simply say on. So on which thing we will be applying the merge? Obviously on product ID. Perfect. We will simply say when not matched, then insert asterisk, and when matched, then update asterisk. But here you need to stop and you need to look at something. We need to add this when matched, and what is and? I will just tell you. And source dot process date greater than target dot process date. Why this command is here? Because let's say you are creating, or you can say you are applying a backdated refresh. Okay, you are historically loading all the data again, and this is a very common command, backdate refresh, in the data engineering. So obviously in that particular scenario, you will not like to update the values of your end table with the old records, right? You should always update the values with the latest version of the data. And that's why even if you just, let's say, bring some values which are bringing process date which is of the older version, it will not update the values. It will only update the values if your process date is greater than your target process date, or you can say equals to. Equals to should also work, but if it is equals to, that means it is already there, so that is fine. That means we can skip it. But yeah, this is the condition that you need to apply. When you run this should work fine, and we can simply say select asterisk from data modeling .gold .scd type 1 table. Let's have a look. So this is our table. Perfect. This is our table. Now I made some changes. Okay. Now our dimension table is changed. Let's say I just change the value of third product ID, and I just say category 3, and I just called as category, or let's say new category. Okay. And I will, instead of saying insert, I should say update. So okay, let's keep it as it is. Let's insert the thing here. So I will simply say update. Okay, and update table name. Pick SQL, update table name, and table name is data modeling dot gold dot SE type, not type gold, source. Default this. Set category equals new category. Okay, set category equals new category, where ID or prod ID equals 3. Okay, let's run this. So here we have changed the source, column, variable, or function parameter category. Don't we have category? Oh, it is called prod cat. Okay, prod category. Okay, so now source is changed, that means values are changed, right? So now what will happen? We simply need to run this cell, which is our merge command. So you will see the magic. We just need to apply merge command, like run merge command, that's it. Obviously before that you need to run source command. This is like common sense. So then if you query the table, you will see your product category will be rewritten. See, product 3 is new category. That's how you handle slowly changing dimensions, but with SCD type 1. This is very straightforward, very simple, and this is something that you will be using most of the time. But yes, we do have some other types as well, and let me just tell you what's that. Let's talk about slowly changing dimension type 2, and this is the thing that is the second most used dimension type, or you can say slowly changing dimension type, that we use within the data warehousing, or you can say data model that we build. Okay, so what is this? So basically this is our previous table, right? So till here, but in case of slowly changing dimension type 2, we create 3 additional columns as well. Let's cover it one by one. First of all, effective start date. That means in this particular dimension type, we need to track something. That's why we are saying effective start date, expiry date, or you can say end date, and in use. So it makes a lot of sense to understand that this particular slowly changing dimension is actually used to track the history of your changes. Make sense? This part is clear? Very good. So how to track the history? That's how you track the history. So whenever you insert any record in this slowly changing dimension, you assign the start date, which will be the current timestamp when the record was inserted. Expiry date, it will be like very big date, or you can say expiry date can be null as well, because if there is no expiry date, that means this is not expired. Or in some organizations, they use a very big date, let's say 1/1/3000. That means this expiry date is so beyond as compared to now. Then in use, that means this particular value is in use right now. Make sense? Just 3 columns. So what will happen when, let's say, this value will be changed? What will happen? Now this value will not be overwritten as compared to slowly changing dimension type 1. Instead, it will create another row here. Okay, this one with the new start date when the value is updated, and expiry date will be so far away from now, and in use, yes, but at the same time we will mark the previous value as expired. See, effective start date is this one, and end date will be the moment the value is changed, and in use the value is no. Now this value is not in use. This way you can keep the track of your changes in your slowly changing dimensions tables, so that you do not need to worry about, hey, what was the previous value? Again, depends upon the requirements of the project, but this is the thing that you cannot negotiate. Hey, this is not used much, so I do not know how to do it. No, you have to just make this, you can say, type of slowly changing dimension in your project if it is required. Okay. Yes, the other types are slowly changing dimension type 3, type 4, type 5, type 6 are not actually required. Let me be very honest with you. In the industry, we just use slowly changing dimension type 1 and type 2. That's it. Rarely we use type 3, but I haven't seen any project or anything in the industry with type 4, type 5, type 6. Type 1, type 2, go ahead. Type 3, good to know. I wouldn't recommend much about type 3 as well. Type 1 and type 2 are good to go. Make sense? So now let's actually see how you can just create slowly changing dimension type 2. It requires some more, you can say, effort. So let's see step by step. We are here in our notebook. Okay, let's create and start from scratch, and this will require some more efforts from you to understand it. Okay, and obviously some more efforts from me to make it easy for you to understand. Okay, don't worry, that part I will do, and I know the other part you will do it as well. So at the end you will learn SCD type 2. Wow, SCD type 2 makes sense. Let's start it. Let's create our source first of all, and I do not want to use the previous, you can say, source. Let's create it from scratch. Let's say create table. Okay, let's create this table, and then let's insert the data. Okay, this is our data. Yeah, we already know that we have the table, so we'll change it to type 2. Perfect. And let's say type 2. Perfect. So this table is ready. Our source is ready. Now it's time to create the destination table. This is tricky. So we know that we need to create destination table like this. Create table, data modeling, dot gold dot scd type 2 table. We know that we need to insert all these 3 columns, obviously, and process date, obviously. Then see, Databricks is really smart. We need to say start date, and this will be date. We need to say end date. Okay, and then date. Then we need to also say is in use or is current, something like that, a kind of flag. Okay, it can be boolean as well, it can be your string as well, it's fine. Okay, let's keep it string, not a big deal, because we just need to filter it. I'll simply say string. Okay, makes sense. Very good. So this is our end table with additional 3 columns. Very good. Now how we will populate this data, this is important. So we know that our source look like this. Select asterisk from data modeling and type 2 source. This is our source, which is the same 3 columns, and that's it. Very good, with process date. Now we need to add some columns as we discussed. Obviously, we will simply add what? We will add start date. What will be the start date if I want to insert or let's say check these data? Obviously, start date will look like this, current timestamp, right? Current date or current timestamp. Current timestamp, I will just convert it into date. Okay, just to keep the flow easy to understand. Okay, and compare as well, because we are just simply using, you can also just, let's say current timestamp, bro. Otherwise you will say, hey, current timestamp. Okay, perfect. And we will simply say as start date. Make sense. What should be the default end date? It can be null, it can be very big date. It's up to you. I will keep it, let's say, very big date, which is let's say 3000 okay, makes sense, as end date, because I do not like keeping my columns null. Then y is as is current. Makes sense. This should be my source. This should be my source. Very good. Perfect. Very good. Now this is start date, this is end date, and that's why I was saying like I should just keep the date instead of timestamp, because these doesn't look good, right? So I will simply say date, because okay, it's fine, because we need to test it as well, so it's fine, it's okay, but you can just imagine that this is also a timestamp, or it is a null, or it is a very big date, right? Makes sense. Or let's say null, I would say, because the thing is, the only concerning point is this is ABC and this should not be ABC. This should be also a timestamp. So we have to use cast function, cast this as timestamp. Okay, and let's try to convert this now. This should be fine. Yeah, perfect. Now this is fine. Very good. So this is familiar, right? This is currently your previous version of dimension that we will be ingesting into your target. Make sense? Very good. But now obviously we need to just see what will happen if, let's say, new record comes. Okay, well, let's say this product 3, let's say there is a new ID, product 4, and it's called product 4, and this is simple, right? Because this will be simply inserted. But let's say product 3 is changed. This is now called new category. So you know that we cannot overwrite this thing. We first of all have to change the end date and is current data. Make sense? Because we want to mark it as expired. Then we will insert another row for third, and we will say product 3, and we will say new category, and same thing, start date, end date, and y. Sorted. Make sense? Make sense? Very good. So now let's try to perform this. This is a little bit tricky, but it is very simple. So first of all, what we will do, we'll simply say source. So let's create a source. Source spark.sql. Select asterisk from data modeling and type 2. Perfect. This is my source. Now let's create the merge command. Merge command will be a little bit lengthy, but it's fine. Dot create or replace temp view, and this will be called as source. Simple. Make sense? Very good. So now, or let's say source type 2. Okay. So now I will say merge into data modeling. Hey, this is not default. Gold, and then SCD type 2. SCD type 2 table. Let's confirm the name so that we will not break our code. Yeah, SCD type 2 table. Okay, and this will be called as TRG. Just a good name. And use SQL. Then I will say using source. Okay. Now on, obviously, trg.product ID and this. Now you need to hold on when matched. When matched, that means if my new data is matching. So currently we are considering the scenario, and yes, it will be a little bit tricky, so you have to rewatch this part, so it's fine. Okay, so let's say first of all our dimension is not changed, it is the same. So we'll simply say when matched. When matched on what? Product ID. If ID is 1 and product name is also same, cat 1 same, process date same, then do not do anything, bro. Then do not do anything. So we'll simply add that condition here. We'll simply say when matched, and you can say source dot product name, product cat, or you can say target cat, or anything. Or I will say not equals to. You can also say double this thing, or not equals to like this. Let's say you want to use not equals to like this. Yeah, you can use that as well. It is saying this is not equals to this, this is not equals to this, and another or condition, because we have third column as well, which is prod name. This is also not equals to this. Only and only then update the value, because if these values are not changed, that means our data is fine. There's nothing new in that. We are fine with that. Then we'll say, then update set asterisk. No set asterisk, because we want to update the value. See, what are we actually trying to do here? We are saying if product category of source of the new data is not equals to product category of the target data, that means we will be having a new category here. In that scenario, we want to update this end date column. We want to say, hey bro, this is expired, make it expired, and we will simply pass the current timestamp for it. Make sense? And this will become no, because this will not be in use. So how we can just do that? Then set, and you will now define what you want to set values. Then trg.endDate equals current timestamp. Current timestamp, make sense? And or you can just move it to the next line as well, it's up to you. Okay, this thing, and trg.isCurrent equals to .isCurrent equals to n. Perfect. Understood this command? Understood? First of all, tell me this. Make sense? Very good. By the way, who will write update here? That's why I was seeing red mark there. Okay, perfect. And I think, yeah, just replace it with comma. Perfect. So now this is half completed. This is just the one part of it, because first of all, we need to mark our records expired. So this particular command will simply mark our records as expired. Make sense? So if you just see the table here, what will happen? It will simply go one by one. It will say, hey, is this record changed? No. Okay, skip it. If this record changed, no, just skip it. If this record changed, no. Yes, then it will simply update these two columns. That's it. This is the only work that this command needs to perform. That's it. Okay. Make sense? Make sense? Make sense? Very good. Now, and as we already have a comment, it is a good one just for you to navigate. So now I can add one more thing. Okay. What is that thing? I can also say, and source dot is current equals to y. Because if, let's say, this record is n, let's say is if it is already expired, then obviously we do not need to worry about that particular record. Make sense? Because that is expired. Obviously, if we have like new updates in the future, that particular record will be having a different value, right? So we do not need to consider the expired records. We can simply say equals to y. That's it. Make sense? So this is the code. Let's try to run this and let's see what happens. If we have any errors, we will fix it. It is saying no table cannot be found. We didn't create the table. I think we just wrote the definition, but we didn't run it. Or we run it. SCD type 2. Oh, spelling. Wow. Just look at the spelling. We forgot to add E. Okay, let's create this table. Perfect. Now, what do we need to do? We will simply apply this particular command. Let's say merge. It is saying src cannot resolve src current in condition given target product. This current target dot is current. What is that? It is saying it is not there in the source dot is current. Okay, it is there. This is our source. This is our source type 2. Oh, see. I am glad it failed. Why? See, we are using source type 2. We either need to remove it here. I think let's remove it here and then use it here. I was like, oh, we were saved. So it is saying is current. Now it is something else. We know that. Okay. Delta merge unresolved expression. Okay. Trg dot is current Oh, very good point. It should not be source.is current. It should be target.is current. Because obviously we need to compare at the target end. Very good. Very, very good. It saved us from our code break. Okay, so this is done. By the way, we currently do not have any data. As you can see, select asterisk from, if I just write the data, I am not able to see anything because we do not have any kind of data, right? We'll simply say dot gold, obviously, because we are simply checking the data for now. We will insert it. What do you want, bro? It is type 2, not type 2. Data modeling.gold, type 2, source, not source, it's table. SCT, type 2 table. So this should be empty. Very good. Now this is just a check that we have applied, right? Now it's time to apply another merge condition to just now insert the data. Make sense? So let's do that. Merge into, what is the destination? Data modeling dot gold dot SC type 2. See, it throws me the grammatical error. See, type table. Okay, merge into this, and I can say as trg, and then using source, okay, on trg dot product id, and this, and we also need to use this thing. Perfect. Now stop here. So now it is saying when matched. No, we are not talking about when matched, just here. Yeah, perfect. So now this is fine, right? This is just checking the condition where you have any kind of match, and it will simply match those things with current values. Makes sense. Now if it will not find anything, then it will simply say, hey, when not matched, then insert, and now you will be just typing all the column names that you want to insert: product ID, product name, product category, process date, start date is current. Okay, then what will be the values? Obviously values will be product ID, product categories, and all those values, right? And actually we do not need to write this thing because we already have that column in the source dot start date, source dot end date. Okay, then source dot is current. Make sense? Very good. So now what will happen, or you can say what is happening overall? So first of all, let's try to run this and let's see what happens. Let's see. So it is saying trg. Why? trg dot is current. What is the error? Syntax error. On this, yeah, we forgot to add and. Perfect. Let's try to run this. Let's see what happens. src dot start date cannot resolve. Insert clause. It is saying I do not even have source date, like start date. Are you serious? In our source we have start date. This is our start date, right? So maybe we again need to run this command, which is source. Okay, so this is my source. Let's run this command and let's actually see what do we have in the source. We never checked it. Source, let's see. Maybe it is right, we are wrong. See, it doesn't even have start date. Wow, man, wow. Because why? Because from tip to source. Oh, now I see, we actually didn't create a view on top of this query. We are required to use this query, and what query we are using? This query. Wow, slow claps. Okay, it's fine. What's the big deal? I was like, why don't we have that particular thing? Okay, now we should have that source. Select asterisk from source. Now we should have everything. Perfect. 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 So now what we will do, we will simply run this command, this one. Let's try to merge it. And then we will, don't worry, we'll summarize everything because I know this is very critical. And let me just show you what will happen. So select asterisk from data modeling .gold.std type 2. It is type, not type 2 table. And you should see std type. Oh man, what is this? Perfect. We have all the things neat and clean with all the additional columns. And now I will tell you what will happen when we just change the data, and then I will just tell you the exact flow what actually happened. Okay, because you need to just see it live, right? And see, this is so critical. This is our data modeling. That's why you are being paid so much, right? So you need to understand all these things. Let's update the data. Let's say I want to update the record in the source. I will say update table name, and it is data modeling type 2 source. Set category or prod cat equals new category where product ID equals to 3. Let's change it. Okay. So now that data is changed in the source. That means data source for the dimension is changed. Now we know that what we need to do. We will simply create this. You can say source, like this is our source query. Okay. We will simply run it. Our source is ready. We will just check if there is any command, if there is any something that we can just update, that it will say yes, we can update. So let's see what do we have here. Okay, let's see. Then it will apply the merge second time, and now I am very excited to see the results. Let's run this. Fingers crossed. Fingers crossed. Okay, I am not able to see right results because why? Let me just tell you why. Because I should only see one new record for product 3, but why it updated all the things, why it added end date for all the records, whereas it only required to update these 2 columns for only and only this particular record, because this category was changed, right? This category was changed. Something is wrong. Let's see what is wrong. So if I go here, we will simply say on this, okay, and target is y, okay, when matched and source product ID cat not equals to this not equals to this process. Oh, silly mistake. What is this? Source dot process date not equals to end date. Obviously it will never match. I was like, what's wrong, man? What's wrong? Oh man, this Databricks. Oh man, see, this was a small issue. Now what is the solution? Nothing is wrong. We simply need to drop our dimension table and we just need to recreate it. That's it. So I will simply say drop table and data modeling dot gold dot type 2 table. Okay, let's drop it. Perfect. It is dropped. Very good. Now let's recreate it from the starting. Okay, this is our table. This is already created like source. Okay, and perfect. And we know that this value is already changed, so we can just rechange this value. Not a big deal, because that's how we can just test our data. So this is a table. Let's recreate it. So this table is there. Okay, now let's run this and this and this, and let's actually see how the current situation of our table. Select asterisk from data modeling dot gold and type 2. Let's see. We should have 3 records. Very good. Now let's update the source. Okay, now let's update the source. Update table name. I won't believe it. No. I will write my own code, bro. I am here streaming and update, and then I will write each and every alphabet of SQL command on my own. Okay, update and then table name, data modeling. I don't even want to, okay, let's use this. Okay, this one. Yeah, so now I don't want to say new category here, or let's say this time we will be updating ID2 because ID3 is already new category. Okay, so let's update this. So this time our ID2 is changed, so we should be only able to see new category for ID equals to 2. That's it. Make sense? So this is done. Let's test it. Let's run this. Okay, let's merge. Let's see what is the result. Fingers crossed. Perfect. Finally. After a great hustle. Good things take time, right? Great quote. So now let me just tell you what actually happened, just to summarize everything. Okay, so what actually happened? So first of all, the current state of the table was this one, y and y. Make sense? So this was our current state of the table without any changes. Yes, new category was already there because we dropped the table, remember, and we just used the updated data for our initial load. Okay, this was already there. Now what happened? We applied our first merge. What first merge will do? First merge will only and only check if we do have any records which are updated, and in our case this record was there and it was updated. So in the first merge it changed this particular, you can say, end date, and it picked the end date of today. Okay, and it said, hey, we are not using this. This is the first merge. Then in the second merge, what happened? We say, hey, first of all, give me all the records which are in use right now, y and y. Make sense? This record was not there at that time, obviously, right? So only these two records went to the source query. It said 3 and 1. It checked the condition, and condition says when it does not match. When it does not match, only then insert the data. Obviously ID3 was matching, ID1 was matching, ID2 was not matching because ID2 was not there, because we just filtered it out. Then we inserted this particular ID2 with these values. Let's say if ID2 again gets changed, then obviously first merge will make it no, and in the second merge we will be having the new value. That's how you just create slowly changing dimension type 2. Make sense? That's how you create slowly changing dimension type 2. I know this is a little bit more complex as compared to type 1, but we do use slowly changing dimension, okay, because we need to track some changes for some dimensions. For some dimensions we do not track it, but this is the procedure to handle all the changes. I hope this data modeling session, end-to-end detailed data modeling session, is really helpful to you, because the thing is, concepts wise it's important, practical wise it is even more important. So I was like, hey Ansh, Lamba, everyone is talking about data modeling. Like all of you are saying, hey, we want to learn data modeling. I was like, yes, there are data modeling content, but what is that gap that I can fill? Then I realized, hey, I can tell data modeling concepts, plus I can just demonstrate through the real world examples, plus real world approach, plus real world use cases as well. So this is the video, this is a masterpiece for you, and I hope that this video will serve every single person, beginner, intermediate and advanced, because data warehousing, data modeling is something that is always evolving. You learn something new when you see something, let's say anything new. It is like never ending topic. That's why more you revise your concepts in data modeling, more you become proficient in this area. So that's all I can say. And just a small request. I know that you respect my efforts. I know you love me a lot. I know that. So just try to add more and more comments. Just try to like this video. Just try to share these videos with your peers, like with everyone on different social media platforms. There are like benefits, multiple benefits. Let me just tell you from your benefit, from your perspective. When you just share your learning with others, you get highlighted. People notice you. Hey, this person is just spending some time to, let's say, uplift his or her skills. First thing is that. Second thing is, we know that this content is really, really helpful. So this content can help others as well. So you are indirectly becoming a helping hand for other as well. So just try to spread these kind of knowledgeable content if you actually like it, right? And I know you like it. So just try to help me and support me. And I don't say like me, I would say us, because I never treated this channel as like my channel. I always say like it is our channel, like me and my data fam. Make sense? So just share this video, hit the like button, just drop some lovely comments, and just tell me like which part did you like the most. If you like slouching dimension type 2 part, I know like this is the heart of this video, because this is something like a little bit professional level, plus we started from zero, right? And see where we have reached. So I'm just looking forward to see you in the next video, and the video is coming on your screen already. So see you there.